Very good morning to everyone again, and I'm Abhishek. Let's start with the session. I'll be your, uh, you can say, mentor or the speaker for the session. And the topic of the session, as you are already aware of, statistical hypothesis testing in Python. So it would be a 2 day session, 15th and 16th of October, today and tomorrow. The timing would be 9 to 11. Uh, so do attend that. I hope you all have the link for tomorrow's session as well. So these are the topics that we'll cover on day one and day two. And on day one, we'll start with what is hypothesis testing, right from the scratch. The types of hypothesis testing. What do you use? Why do we use basically hypothesis testing? And then again, we'll come to Python basics, where in which we will cover NumPy, Pandas, Matplot, and Seaborn. It's not like I'll give you an introduction. Okay, this is NumPy, this is Pandas, this is Matplot. You can do this using this. Okay, it won't be like that. It would be something like I'll have the Google Colab sheet with me, and I'll share the sheet with you as well, and then we can start. So we'll go into and get our hands dirty on the code. So that's how we'll go about in this session. Okay, so it won't be a completely introductory session. For introductory, it would be for hypothesis testing and types of hypothesis, and hypothesis part, it would be somewhat introductory for this day one. And for day two, we'll start coding and going into detail of hypothesis as well. But to make everyone on the same page, uh, I'll go in the day one. I'll go with the basics of Python, starting from NumPy, Pandas, Matplot, and Seaborn, so that everyone is quite familiar with Google Colab and environment uh, and coding part. Okay, so this is how we'll go about. And day two, type of hypothesis, type one, type two error, chi-square test, and resources. Okay, so this is how we'll go about. Honestly speaking, I don't know that. I'll confirm you with the once I'll ask the organizer and we'll confirm you that by the end of the session. Sure? Will that be fine? I guess. Cool. Okay, guys. So let's start with day one. And before starting, there would be few points like I'm using a split screen. So it might my presentation is on this side and I'm taking your question on the this side where I have my camera. So it would sometimes look like I'm watching here and you are here. Okay. So kindly bear with me in that because if I enter in the slideshow mode, it will stop sharing my this screen and the notes of the screen will appear. Although I don't have prepared notes for this presentation, but again, blank screen would appear on the screen. So that's why I'm not entering in the slide mode. Also, I have kept your questions because I want you all to ask the questions. In meanwhile, as well as what I would personally prefer is asking in the end because there are a couple of many things that we have to cover in day one. Okay, so once the day one is over, I have dedicated a sufficient time to that Q&A part. Okay, and then there you can go. We can discuss our questions, and also we have day two as well. If you go back home and learn hypothesis testing on your own, try searching over the internet, try coding it, and if you have any doubts, we can have it in day two as well. Okay, so that is what I would prefer, and this is how we go about in this session. In if in case you are asking your question in the middle, I might not take that at that point because it might be in the somewhere in the day two part or it might be somewhere in the day one part but in the end, so in the end you will get the answer. If in case you don't get the answer, you can type in the chat again in the end of the session and I would take that. Okay, I hope this is cool with everyone, and yeah, without wasting any more much time, let's start then. Okay, so a big question that we all are here for, what is hypothesis testing? So hypothesis testing is a statistical method that is used in making statistical decision using experimental data. Okay, so hypothesis testing is basically an assumption that we make about the population parameter. Okay, using on the population parameter using the sample data. So basically we'll define mostly two statements. One is h naught and other is ha, or you can say h0 or ha. Okay, h0 stands for null hypothesis, ha stands for alternative hypothesis. Okay, so uh, it's a kind of theoretical topic. In the start it will look like a theoretical topic, but in the end of by the end of this particular day one, not for this day one, but in the starting of the day two, we'll start the coding part of hypothesis as well. Okay, so in the start it might look like a theoretical topic, but it is not. Okay, so we have to start from the basics, very like hypothesis, statistical method. So in order to let's say I am making a fact. Okay, let's say you say that average student in a class is 40. Okay, or let's say a boy is taller than the girl. All those examples that we assume need some statistic way to prove those, right? So we need some statistical or mathematical conclusions that that we are assuming this to be true. Okay, so we'll have some mathematical assumption, we'll make some mathematical assumption. We have the sample data, uh, we'll try to what we'll try to verify whether the assumption we have made is correct or not. Let's say we have made an assumption on h0, that is null hypothesis. The null hypothesis will make an assumption. Okay, the average age of the student, average age of the student in of all the students in the class is 22. Okay, so this is h0 that we assume. We have the sample data. Will have mean, mode, median, all those statistical data we have, and we try to verify whether the hypothesis or the assumption that I have made is correct or not. And if it is correct, we'll accept that okay, it's not or null hypothesis correct. Otherwise we'll go with alternate hypothesis, ha. Okay, so this is what hypothesis testing in short or in layman terms is about. Okay, you can see on your screen, it's very good example of this. I believe the population's mean score is 20. Reject hypothesis or not close, kind of this. Okay, so he was making comment on the population side, and the random sample or the statistical data it has was mean equals to 20. Cool, guys. So this was hypothesis testing. Let's move forward. As I explained you that there are two types of hypothesis testing. Testing, again, testing, there are 17, 18, many n number of tests, many number of tests for that we use for hypothesis testing. But there are different tests, like type 1, type 2 are error. There are different tests, but will not go in detail of type of test. What we are studying is type of hypothesis, not type of hypothesis testing. Okay, so as I explained, there are two types: null and alternative, h0, h0, whatever you want to call it. So h0 is at as it is already explained in on your screen. I'll just go through that. So it and in an inferential statistics, the null hypothesis is a general statement or default position that there is no relationship between two measured phenomena or no association among the groups. Okay, h naught will assume that there is no assumption or there is no relationship between the two measured phenomena, and and there is no association between the groups, and we'll assume this particular statement and we'll go forward with this. Okay, in other words, it's a basic assumption or made based on the domain or the problem knowledge. Okay, for example, let's say a company, we can assume that a company production is around 50 units per day, something like that. Okay, so this is a null hypothesis that we have assumed. Now we'll take the company's data, production data. We'll try to verify whether this is correct or not. Okay, uh, uh, just give me 1 second. Actually, guys, try to unmute, mute yourself when you join the meet. uh, it might create disturbance for others. Yeah, cool. Okay, so that was null hypothesis for you, and alternative hypothesis, HA, you can say. The alternative hypothesis is used in hypothesis testing that is contrary to null hypothesis. It usually taken to be that the observation are the result of real effect with some amount of chance variance superimposed. Okay, a company production, let's say in this case, we can take an example of the reverse of what we have taken in null hypothesis. That is, a company production is not equals to 50 units per day or something like that. Okay, so this is the other hypothesis that we have taken. So these two statements must be exclusive. Exclusive means if one is happening, other won't happen. Okay, let's say there is a match between India and Pakistan, and we are assuming that there is no system of tie or draw. Okay, and then if you say like okay, one hypothesis can be India will win the match. Okay, the let's say null hypothesis, India will win the match, and the alternative hypothesis would be India will not win the match or Pakistan will win the match. Okay, so these are two exclusive statement, right? One cannot happen with other, right? Both cannot be true simultaneously. If one is true, other should have been other would should be false. Okay, so this is how this is what we deal in an hypothesis testing. Okay, on the screen you can see a very good example. Uh, can include equals to, less than equals to, greater than equals to, all these signs. And alternative hypothesis generally includes not equals to, greater than, less than, all those signs. Okay, moving forward, why do we use hypothesis testing? That is very important question. Why actually we use hypothesis? Why the need of this hypothesis arose? Okay, so a hypothesis is a essential procedure in statistics. A hypothesis test evaluates basically two mutually exclusive statements that we have already seen, H naught and HA, alternative and null hypothesis, about a population to determine which statement is best supported by the sample data. We'll have some sample data, we make some assumption, we'll verify whether according to that sample data, which exclusive statement is uh, correct. Okay, when we say that finding it is statistically significant, it it's been done by a hypothesis test. Okay, there are few things more to add on, like the basics of hypothesis is based on normalization and standard normalization. I hope most of you might be aware of these term, normalization, standard normalization. And so although all our hypothesis revolves around these two basic terms, and yeah, we'll study that in tomorrow's class. But for this instant, I just want to introduce these two terms, like normalization and standard normalization, so that uh, you can go Google it if some of you wants. Okay. Okay. So you standard normalization. I think you must have seen that standard curve, standard bell shaped curve for normal distribution. So yeah, that was the thing. And yeah, there are few many terms which are related, like p-value, uh, or you can say type 1 error, type 2 error, one nail test, two nail test, and degree of freedom, t-test, one sample t-test. So all those things will two sample t-test. So all those things will cover in, I think, day two. That is in day two only for us. Okay, in day one, this was most of the things that we need to cover in terms of hypothesis testing. So it was just to give you a basic introduction. Now I'll switch to my Google Colab. Okay, and yeah, so this is what we are now going to start. That is from Python basics, NumPy, Pandas, Matplot, Seaborn. So let's get our hand dirty with NumPy and Pandas basics. Okay, so I'll stop sharing my screen. I have to share other screen. Okay, so what I would request you to do is you can I'll share my screen and I'll show you. Let me know, guys, if my screen is visible to you. Right? Okay. So what I want you to search is search Google Colab. Okay, on the Google. Okay, please do it with side by side because it is important, right? Yeah. So open collab.research.google, and here what you can do is you can uh, create a new notebook. You can click on the new notebook, and a new notebook would appear, something like this. Okay, a new notebook will appear. Okay, please do this and let me know in the chat if you are ready with this, because this is what we would be using for our coding part. Also, if you don't want to go do it online, uh, you can install Anaconda, you can install other software as well. Spider you can use. So all those other software you can use as well. So it's up to you what you want to use. But in this session, we'll go about Google Colab because it's easily accessible to everyone, independent of the your system configuration mostly. Okay, so a few people are ready. Let me know if everyone is ready, and then we can start. We'll start with NumPy, and I hope you guys you have idea about NumPy. Any idea about NumPy, Matplot? Anyone have any idea about NumPy? No. What about others? Yeah, some people have. Okay, cool. So these few things might be repetitive for you. Sorry for that, but I want everyone to be on the same page. Yeah, because some people are messaging me in a direct message that they don't have idea of much. So yeah, also knowing what is important for the session is again important. So yeah, okay, cool then. Thank you guys, and let's start with. I have to mute few people. Guys, if you want to, if you are speaking something and I have in case muted you, you can write in the chat or you can raise your hand. There is, I think, a hand raise method as well. Yeah, you can raise your hand and I'll unmute you. Okay, cool then. So this is Google Colab, and this is how it will look like. So this button is to run this particular line. Okay, there can be many lines of code you can write in the same cell. Okay, this I call it cell. Okay, and currently I want to write only one line. Let's say you want to add cell, when you want to run cell, you have to press control plus enter. Okay, and the cell will run something like this. Okay, you can say currently I have not written anything, so it won't much make any difference. Okay, on successful completion or execution, the cell will without an error, if your code is if this cell code is executed, it will show some green tick like this. Okay, I'll zoom my. So that, yeah. Okay, so let's start with mm, okay, cool. Let's start with installing NumPy. So this is how you need to install NumPy. It's pip install. Pip command, I hope you everyone know. Uh, Pip install NumPy, and to run, in order to run, I told you that control plus enter you need to press, and it will look something like this. For my system, it was already installed. So it will come up like this, requirement already satisfied. Some of your system as well, it might come like this. Okay, but we have to do this step. And now in order to add another cell, you can go here and yeah, you can add a code as well, or you can click on this and a code cell will be added, or you can press control plus m plus b, something like this. Control m plus b, and you can add many cells together itself, so that you don't have to create have cells every other time. Okay, now uh, in order to use NumPy, we'll import NumPy. Okay, so we'll write the command, sorry, import NumPy. Now importing NumPy, but as you already might know that importing a particular library we don't use it as its own name, because again, for using any functions or any methods I want to access, which is defined already defined in this library, I have to every time write complete numpy. So how I call it, let's say the function name is f. Okay, so every time I have to call f, I have to write list f dot numpy, or numpy dot f, numpy dot fun, let's say, or any variable I want to access, I have to write numpy dot. Okay, so in order to make my work easier and my life easier, what I usually do is what we generally follow in the industry as well is import numpy as np. Any short form you can give, x y z, but x y z, all those things we generally use as the name of the variables. So np make more sense to be used. Okay, also it will resemble to the library we are importing. We'll import matplot as plt, all those things will also do, but for numpy, it is np what we generally use. Okay, so import numpy as np, and if you play it, it will be executed successfully. Okay, let me know if you are done with this step, any error if you are facing till this step. Hi Sohail, good morning. So we have just for all those people who have just joined, we have started with the basics of NumPy, Pandas, and Matplot and Seaborn. We'll cover this uh, in our time, and after we have seen a few basics of hypothesis testing. Don't worry about those basics. I will cover that. If you have, I'll share with you the presentation, and you can see that at your own available time as well. Done, guys? Yeah, it's clear. No error is coming. That is important. That there is no error in your code. Okay, cool. Okay, cool then. It's easy. It's easy. I know. For few people, it seems very easy. Yeah, but please bear with me. Bear on that. Will come on a good part as well. Okay. Now, imported. We have imported NumPy. Now let's so in NumPy we have, so what basically NumPy is, I forgot to mention that. So NumPy is a Python library that is used for working with arrays. It has specialization with working in arrays, and it has also has for functions for working in domains of linear algebra, Fourier transform, and matrices. NumPy was created in 2005 by Travis, and it is an open source project, and you can use it freely like what we are using. You can access its official documentation as well. NumPy, it's a short form of numerical Python. Okay, num numerical and py Python. Most of the people don't know this. I was not aware of this when till now, but when I was preparing the content for this particular session, I came up to that, because we generally use NumPy in our daily life. Like I have used hell lot of time NumPy, but I have never gone into, okay, this is the full, this can be the full form of NumPy. So that is something. Yeah. And so in Python, we have lists that serve as the purpose of the arrays. Okay, but they are very slow to process, if you know. Okay, but in NumPy, it aims to provide 50x faster than a traditional Python list. So it is what it is claimed by the developers, that it is 50x times but than the Python list. So we'll see that the power of NumPy in this coming time. Okay, and the array object in NumPy, I'm telling few things in the start so that it will create a base for you guys. So NumPy array object is called ND array, ND array. So it's like this, NDARRAY. We'll also ask the NumPy to print this. So it's like this, ND array, and it has a lot of supporting functions, and it is very easy to use. Okay, arrays are very important part in our in our data science journey and in our data science life, and where speed and resources are very important. Okay, I hope you are aware of what data science is. I'm not explaining you that. And NumPy, most of the codes of NumPy is written in Python. It's a Python library. Some of the codes are written in Python, but for faster computation, they are written the other part is written in C and C++, because you know C++ is faster. Guys, meanwhile, one question arise in which was one of my interviews question, that which you think is an faster, which you think is a faster language, C or C++, assuming that C is quite old. What do you think is faster, C or C++? C++. Okay. 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 What about others? Okay, since it is a newer language, yeah. Okay, so most of you think that C++ is faster. Hmm. Okay, what about others? What do you think? And what about Python? Is Python faster than C++, or Python is comparatively faster? Although I have told you the answer. Uh, you will be shocked to know that C is the fastest language, and yeah, so C is the fastest language. Although the C++ is a newer one, C++ has more integration. Actually, C was the pure binary language, and it is without bias, the fastest language we have. Okay, and C++ has more integration of libraries, function, and all those things. I'm coming with I was looking for some data so that I can show you. After compiling, if you run the code, it takes about 2.42 seconds to generate all 67 millions lines of code, and it means Python take 25 more time to run the same algorithm compared to C++. So Python is way more uh, slower than C++. Yeah, it bound to be slow. Yeah, cool then. Python is slower. Yeah, obviously. Cool then. Let's come back to our topic. It was some. Yeah. So NumPy, you can search on the NumPy code base. I'll send you the link in the last of the session, in the last of the NumPy class. The actual code base of the NumPy where the official documentation is there. Okay, so installation part we have done. We have imported NumPy. Let's quickly get started with the array part. And yeah, someone was asking something. Uh, Shishir, I have to look into that. Just give me 1 minute. I'll ask them and I'll let you know in 1 minute. Once I get the response, I'll definitely tell you in the chat. Don't worry. Okay, cool. Till then, please enjoy the session. Yeah. That's what I can say. Okay. So let's start with the array part. So we'll define an array with the name ARR, and NumPy will use, and NumPy has its own method, array method. And in that array method, we can pass the list. I hope you are aware of how the list is defined. So list is defined in the square bracket format. So let's take this as the list of us, and let me use the print statement to print this array. So if I click on the control enter button, it will print. This will give me the output. Okay, so this is how we make an array, and this is how we'll print an array in NumPy. Cool. Now, if in case you want to know, okay, sir, you have told that there is NumPy. So, but what version of NumPy are we using? Are we using the latest version? How many versions are there? So, what version my current system is using? So, just I want to know that. Yeah, certificate would be there, but it would be provided after you have completed the the you have completed the 2 days, the complete 2 day of the webinar. Cool. So that is what the info I got from for you guys. Cool. And so let's see what version of NumPy we have. So it would be print np dot underscore version. So it would be dot underscore underscore and version underscore underscore. Yes. Hopefully this will learn. It will give us the version of NumPy that your system is currently using. So yeah, we can Google this as well if this is the latest version. Okay, so let's Google this. What is the latest version of NumPy? I'm also not aware of the exact version of NumPy. So it is NumPy 1.23.4. Okay, and we are using 21.6. Yeah. Okay, no worries. Let's uh let's deep dive into what we were what we are currently doing. So array defining of the arrays we have done. So what I was telling you was that the array object of the NumPy is called nd array, right? So the type of the array would be, let's use the type function. Let's use the type function to see what is the type of the array. So it will print me nd array. Look, it gives me numpy dot nd array. So and the numpy is already telling you that I am using the type of the array is nd array. Okay, so this is the array object used in numpy. Cool. So basically this type function is an inbuilt function in Python which tells you the type of the object passed to it. Okay, like in the above code it shows that arr is numpy dot nd array type. Okay. We can, in order to create such type of array, you can pass a list or tuple, or mm, yeah, you can pass a list or tuple, or any array like object into the array function, and it will be converted to nd array. So this is another method to convert any Python object into nd array type. Cool. Let me give you an example of passing the tuple as well. We convert into the array, right? Cool. Okay. There is another concept of dimension in arrays. Okay, and so there is generally zero D array. Okay, we'll start with zero D array. So zero D array is something like, uh, let me define it again. This is how a zero D array looks like. Simple, a number would be there. Let's say 10. Okay, and print. Yeah, so 10 will be printed. So this is an example of zero D array. 1D array we have already seen something like this. I'll make a list out of this. Okay. So this is example of 1D array, one dimensional array. Now 2D array, coming on to 2D array, the elements are mostly presented in the form of matrix or 2D ordered tensors. Okay. NumPy has its own dedicated submodule towards matrix operations, which is called numpy.mat. Okay. It's a separate submodule dedicated to matrices or matrix, you can call it. Okay, now in order to define an 2D array, we'll do something like this. They will be separated by comma. Okay, now one, two, and they would be enclosed in square brackets. It basically shows that this is, let's assume this a particular array. Let's say it was x, it was x, it was x. This x is now the 1D array, and this is another y, and this y is also 1D array. And because of them, the each element is 1D array. That's why this complete array is 2D array. You can say it like this. Okay, that's how I remember the syntax of 2D array. Okay, cool. If I print it, you can see it is printing in the form of matrix. Cool. Now coming on to 3D array, as the array has 2D arrays as its element, it is which the if an array has 2D arrays as its element, it is called 3D array. The same logic. Okay, so I'll make the same thing out of here as well. I'll quickly copy paste this. I don't want to waste your time in typing. Okay, and another square bracket we need to add, and this will convert into the 3D array. Mm. Yeah, this is how the 3D array looks like. Although in the 2D screen in the computer we can't show it on 3D. Okay, but this is how it shows a 3D object. Cool, guys. So this was the 3D array. And if in case you want to check the dimension of any array, so this is the method you would use. You need to print name of the array dot. There is a attribute called ndim. You can use this, and if you run it, it will print you the dimension of the array. Currently, it's 3. Cool. Uh, yeah. I hope I'm not. I'm not. I should not test other dimension as well. It would work, right? Let's not waste our time on doing that. Okay. What about higher dimension array? An array can have any number of dimension. You can see it. It will start coming down and down, and you can assume 5D array as well. So in order now, sir, okay, we can write till 2D array or at max 3D array we can write. But how about 5D array and all, any array above, any array having more than this dimension? How to write that? So yeah, there is a shortcut as well. Let's define arr1 with the name anp dot array. And what you have to do, let's say you have to create an array with 5 dimension and verify that it has a 5 dimension as well. So this is the method you can use, and you can mention the value of uh, ndim, yeah, ndim and value you can give 5. Print. This is how the 5D array looks like. Okay, guys, let's quickly move to the indexing part of the array. So array indexing, I hope you all are aware of this term, array indexing. And let's move that now. Cool. Okay, I hope you all are aware of the indexing, what indexing means, guys. Yeah, all of again, I'll explain in quickly 1 minute. So array indexing, or in general, the languages in languages, the indexing starts from 0, meaning that the first element has index 0. Okay, and the second element has index 1, and so on so forth till n minus 1, n be the number of elements in that particular array or in that particular storage data structure, you can say. Okay, so I'll define a comparatively uh, uh, smaller array so that we can understand this properly, and then we'll move to the complex part as well. Okay, so I want your support in this. I need your quick answers for that, so that I'm able to understand that you are getting this point. Okay, so this index is 0. This, if I want to access this element, I have to use index 0. For this element, I have to use index 1. For this element, I have to use index 2, 3, and 4. Okay, why this index is 4? It is till n minus 1. There are 5 elements, and this index last element index is n minus 1. So remember that. Okay, so I want you to quickly answer me this question. Print arr of 2. Print arr of 2.
3.
Yeah,
3.
yeah, great. Cool then. Yeah, most of you are, I think, getting that. No, Sanjay, it can extend to other dimensions, higher dimension as well, not limited to 1D, 2D. It's not nd dot array, it's nd array. It's the array object basically in that is in NumPy. So it's the name of the array object basically. It's not something meaningful. It's nd array. Okay, cool. Then yeah, I hope you all are correct. It's 3. It's going to be 3, and 0 index is 1, 2, and 3. This is the number at second index. Okay, so it will be 3. Okay, so other small examples I'm not taking. Just a small example. Will this operation is valid or not. And if yes, then what is the answer for that? If you think this operation is valid, let me do the answer for this.
It's 8.
Yeah. Few people are saying 7, some are saying 8. What about others? Yeah, 8. Yeah, yeah, no worries. You can't. Yeah, obviously you must have done some calculation mistake, silly mistake. No worries. Sort of. It's still okay. Cool. So it is valid, and the output would be 8. Why it won't be valid? Array 2 we can access. Array 4 we can access. Okay. But what if I make array 5? What would the output for that? What do you think? I know for most of the people it's an quick basic class, but believe me, you will learn a few things at the end of the class. There's always something to learn what you have already learned. So yeah, please stick to that. Yeah, slicing, all those things will cover. Error, yeah, obviously it will give us the out of bound error. Uh, yeah, out of bound error it will give. And Google Colab has this very cool feature of searching Stack Overflow directly. If you click on it, and it will go and search the complete on the Stack Overflow, and you will get very accurate result, because they both are from Google obviously, and they know what keyword they want to use. So yeah, that's why. uh, yeah, so ARR of 5, the index 5 does not exist. It's only till index 4. So index 5, there is no element till index 5. If I've increased it to 6, then the output would be 3 plus 6, that is 9. Now it is not out of bound because we have ARR of 5, right? Cool, then most of you are getting this point. Cool, great. Now accessing of the 2D array. Now this is the part where the things are becoming interesting. How to access element in the 2D array. So that is very important. Let us make a 2D array out of this. And I generally take this example only. Yeah. And so this is how you need to access, separated by comma. The index should be separated by comma. The first element would be tell you the row, and the second would be telling you the column. Okay. Think of a 2D array. For imagining this, for doing this, think of the 2D array as a table, a 2D table with rows and columns. So rows like this and columns like this. Okay. Uh, so the first part will represent the rows, and the first parameter of this will represent number of row, and the second will represent the column. Okay, so I'll print that and we'll get an idea of um what how yeah, yeah, sorry, square. So this is how the 2D array looks like, and let's say I want to access this particular element 3. So can you quickly tell me in the chat what should I write? It should be written something like this. Okay, there would be x, there would be y. The x and y I'm searching for. I want this particular element 3. 0 comma 2. Okay, what about others? What do you think? 0 2 is some sort of saying. No answers. 0 2 0 1 3. Okay, now the things are getting interesting. Okay, by the way, how many of you are in Bangalore? It's out of the session question. Is someone of you based in Bangalore, currently in Bangalore? Okay, Sanjay is there. It rained pretty heavily yesterday. All night it was raining. The roads must be jam packed by now. Hopefully, it's good that it is not a working day. Otherwise, it would have taken hours to reach the office for a few people. Yeah, yesterday it. Okay, cool. Yeah, 0 comma 2 is the correct part, I think. And let's do that. Let's test it. X and Y not defined. Oh, Rohan, basically, I was asking for X and Y. What would be the value of X and Y? It should be some of form X and Y. It's not like X and Y. I'm writing X and Y. It was like X and Y. You have to tell me. So X and Y is not defined. Not the thing. Okay. So 0 comma 3 is 0 comma 2, sorry, is the value of the 3. Okay, 0th, I told you this will represent row and this will represent column. So again, it is an indexing, so it will start from 0. Hard luck for all those who think that it will start from 1. It's the learning for you that always the indexing starts from 0, whether it is 2D array or 3D array or 1D array. The indexing starts from 0. And so 0 comma 2, 2 why? Because it's the third column, so that's why column number 2. Yeah, cool guys. Yeah, so that was all for 2D array and accessing all those things. Okay. Similar the case goes with 3D array. I'm not going to show you that. Let's You can add another Z where Z is defined, but you have to tell me what Z is. What you have to define what Z is. Okay. So that Z represent the Z dimension or the third dimension of if you have taken the 3D array. So it's up to you. You can try it at your home. Okay. So 1D, 2D we have covered. Cool then. There is another concept of negative indexing. From the end we use the elements, like from the end it's -1, -2, -3, something like that. Okay, so let me take a simpler example and let me show you that. Can anyone tell me the value of this? It's 4. Yeah, cool. It's 4 because this would be taken -1, as I mentioned. This would be -2, -3, -4, -5. Okay, so -2 would be 4. Cool. So this is the concept of negative indexing. Very simple. So again, you can use it for negative for 2D array, 3D array as well. So it's not of much issue. Okay, slicing. Now let's come to very important part, that is slicing, array slicing. Basically, guys, you want a 2-minute water break because I am feeling thirsty. Do you want a 2-minute water break? My bottle is empty. Right. Yeah, 2-minute water break would be good. What do you say? You can grab some coffee or some tea or juice, something, or water. You can. Yeah, sure. Okay, see you in a couple of minutes. It's 9:56. We'll see you at 9:58, and we'll start from here. Okay, see you. Yeah, slicing in Python takes element from one given index to another given index. Basically, it's like a mango slice or any slice you can imagine. It's a slice of a bigger portion. Okay, slicing means cutting a smaller portion of some bigger part. Okay. Uh, we pass, so basically slicing, in slicing we pass the slice index from the start to end. That is what our intent is. Okay, and we can also define the numbers it want to take. Okay, let me give you an idea of that. So this is the array we are having. uh, let's say I want to slice this array. What I want, okay, uh, I've told you that, let me tell you this first. This would be the start index and this would be the end index. Okay, you have to tell me. There is only one way to keep you active in the session, that is by asking the question. So that's what you will also not get, some of you who already know will also not get bored or something like that. Okay. Second session, just tomorrow at the same time, 9 to 11 it would be, and we'll look into the hypothesis testing there. What is hypothesis testing basics we have seen, but we'll go into deep dive into the coding as well as the error and all those parts of hypothesis testing. So you can join that as well. Enjoy the session. It won't be much long now. Already more than half of it has been passed, so it won't take much time. Okay, cool. So slicing. Slicing would be the last topic, I guess, for the arrays, because the array is infinite in number. So will the numpy, for the numpy basically, it would be the last, and we'll quickly jump to matplot or something. See, pandas most probably will jump into. Okay, so you have to tell me if I want this particular slice from this array, 2, 3, and 4. What would be the value? What should I write? Array of this comma, this colon, this. What should I write? Array 1 to 4. Okay, where this represents starting index and this represents ending index. Let's see if you know that trick. 1 is to 4. What about others? 0 is to 4. Okay, 1 is 4. Okay, yeah. So its index is 0, 1, 2, 3, and 4. 4 index is 5. So the trick here is the starting index will be included. So we'll keep it 1, because we want the end value from 1. Okay, but the end index will not be included. It will be sliced till the end. Till the end means end index is not included. The element at the end index will not be included. So we'll keep it 4, because we want elements till 4, right? So we'll keep it 4. It's not like that. It's like 5. The element 5 is having the index value 4. So we don't want 5. We want just before 5. That is 4. Okay. So we'll keep it 4. Guys, if I hope you are clear. If it was 9 here, still the answer would be 4. It's not like the we want till 4, so we have kept 4. It's not like that. Okay. Yeah. Cool then. If I write this, if I so you will get 2, 3, 4. Cool. So this is how the slicing is done. Okay, and let's say what you want to do is you want an alternate numbers. I don't want all the numbers from 1 to 4. Or let's say I want all the numbers from 1 to 5. Okay, so what I will do, I will keep this empty. I hope it would work. Will take from starting index by default is the 0th, and end index is by default is n. Guys, what's the end index, by the way? What do you think? What would be the by default end index? Would it be n or n minus 1? Um, like n or n minus 1 for this. This is the 5 array. You can answer obviously 5 would be a good answer. Minus 1, no. Minus 1, no. How it can be minus 1? The last index. I'm asking in terms of slice. The by default index of end. If I kept it empty, the start index would be 0, but what would be the end index? N minus 1. Length plus 1. Okay, that you means it would be 6. Suppose. Okay, I think Sohail was correct. It would be n minus 1. And no, sorry, Sohail was also not correct. Someone was correct. Sohail was correct to n. Sohail, you write 5 and then you typed n minus 1. So 5 is n, and n minus 1 would be 4. So the answer would be 5. Basically, that is n. Yeah, because we will take the values till n minus 1, because right. Cool, guys. Okay, so let's say you want alternate index. So there is another third parameter which tells you the number of steps you have to take. By default value of it, when it is not defined, it's 1. That every other element we want. If I define it like 2, so it will take every other element, like alternating element. It would take. It won't take the continuous elements. So 1, it would take 1, then 3, then 5. Okay, cool. So this was the concept of it. Yeah. So L is very smart. You know, thanks, Sohail. So minus 1 will give you the array in reverse order. So that's easy how, and that's the power of Python. The code will be small, but the computation time might be take long, but the code is very small. Okay, this is how you can reverse an array in Python. Cool then, guys. I think that was all. काफी हो गया array के लिए, numpy के लिए. That was all for numpy. And let's quickly jump to the pandas basically. Yeah, good with numpy. So this was all we have to cover. We had to cover in numpy. Yeah, yeah, Google Colab dot. Yeah, I'll share that Google Colab sheet. I'll share that. Don't worry about that. Share that. Okay, let's quickly jump to pandas and we'll see how. we work with pandas. Yeah. So pandas basically, NumPy was used with arrays and all those things. Now pandas is a library used for working with data sets, and it's the name pandas has its reference from panel data. It's not the panda animal. It's from reference is taken from panel data, and Python data analysis. Uh, it was created by McKinney in the year, I guess, 2008, and it has a function of analyzing, cleaning, exploring, and manipulating data. Some of you was writing like he or she is working in 1 year from data analyst. Yeah, Krishna was working as a data analyst, right? So you must be having you must have to work with pandas, right, Krishna? So that's what panda is, working with data sets. And why do we use pandas? Pandas is used to analyze big data, make conclusion based on statistical theories. Pandas can clean messy data sets and make them readable and relevant. And relevant data is very important for our data science project. Okay. Yeah, so let's go into the pandas. I'll share the code base of pandas in the end of this class. I'll share the code base of NumPy and pandas simultaneously with you. So yeah, let's quickly do the same for pandas. It will install pandas. Let's see how it tells requirement already satisfied. It says okay. Seems to for me the requirements are already satisfied. Give it a try in your system. Okay, and let me know in the chat if you are done with installation part. Till then, I'm importing pandas. We'll import pandas as PD. Okay, that's what we use. Okay, let's go to the import. They have imported. Give do guys do give me a done or something, why or something in the chat so that I can come to know that you have done with pandas installation at least. Then yeah, cool. Okay, I hope others might have also been, yeah, others are, yeah, cool. Cool then. Now pandas is been imported and it is ready to use. And yeah, so let's start with pandas. So it takes the data in form of dictionaries. I'll keep this import statement separate, and let's use the uh, let's name my our data as my data. And this is in the form of dictionary. So let's say it is car and colon, and let's say it may be uh, let's see, let's say consumer vehicle I-10, maybe I-20, and Alto. Is Alto spelling correct? AULTO. I don't know. I don't know. Then comma separated by then let's say mm, a number of wheels. Wheels. Okay. Although everyone has 4 wheels, but again, in order to keep it differentiate, I'll write 4, 5, or 6. Okay, in order to differentiate. Otherwise, all of them, that have 4 wheels. Okay, now in order to convert that into a data frame, the data frame is the thing that Panda uses. It was NumPy for NumPy. We use array of method in NumPy, and in Panda's library we use data frames. Okay, so I'll convert my data into my variable using the data frame. Right, so I'll write pd dot data and frame. Just one time you have to do this. Once your object is converted into data frame object, it would be, your life would be good. Data, and I want to print this, so I'll write again the print statement. And let's see. Okay, so this is how it will look like. So basically tabular data structuring data. So all those things the pandas deal with. Cool guys. So this is how you make any object to the pandas object using data or data frame object. Cool. Now All this part, it is called alias, right? Alias it is called, right? Okay. Now again, the checking version of pandas, you can do the same thing. Print PD we are using, so underscore version underscore on this. We can see this 1.3.5 is the version of the pandas that we are using. Why it is necessary? Because in some projects, or the people who are working in the industry might know that uh, for some environment, for some libraries, they only work with specific version of other libraries as well only. Okay, so that's why it is important to know how the what's the version for pandas, so that we can reinstall it or update it, or use it accordingly, right? So yeah, that's the thing. So now we'll come to panda series. So panda series is nothing but it's like a column in the table. Okay, there you can assume a table, and there one column, you can say it's a panda series. So it's a one dimensional array holding a type of that was same as the in the case of numpy of array. Okay, that's the same. Okay, so I'll write in this. Okay, so let me define a list. And what I will do, I'll define my variable again. I'll initiate it again using the series method. You can convert anything to series using series method. Basic methods we have to see, so that if in case you need something in data cleaning, data processing, pre-processing, so it might be helpful for you. The pandas, numpy, matplot, so data visualization, it uses matplot and Seaborn. So all those things you should be aware of. Okay, so series A, and it will convert this my variable into series. And if I print my variable, it will print the series. Yeah, this is how it will look like. Cool. The D type is the type of the numbers you have kept. It is int 64 bit basically. The index again, we can you can index that. You can access them using the index. Again, this index starts from 0. You have to index the my variable, not the ARR. Obviously A is the list, you can access that, but my variable is the series we are interested in. So if I write 1 here, so 1 would be 2, right? I where value would be 2, so 2 would be printed. Cool. Okay guys, so that's the index or label, you can say, for pandas. And yeah, so in let's say if you are given a table, you want to add your own labels to associate it with a particular series. Let's say this is a series. When I print this series, it only has uh, it only has one column. Okay, I want something like this. I want to add a column like cars. Okay, but it would be of my choice. So what I would do is this is what I have to do. My where equals to pd dot series, and in the series I'll write the uh, series, or the list which I want to play with. And then I will write index equals to, sorry, index equals to any index value that you want. Let's say I'm currently using x, y, and z for this, and w as well. Okay, and let me print my where updated my where. And you can see x1, y2, z3, and w4. They have been labeled. Okay, so this way you can add them. Cool. You can also access the elements using my aware of y, and it will give you the value. Let's say I want to access that my aware of y, and it will give you the value of 2, right? So it's up to you. Okay. So yeah, recording you will get the recording. Yeah, you will get the recording for that. But I would suggest you to I would personally suggest you to attend the session in the live mode, although it's not more than 30-40 minutes left. So you can go to their YouTube channel and Okay, guys. I think that's the feature of Abhishek. That's the feature of Google Colab. Although I have not checked that personally. Sometimes I just use this feature, so you can check that on internet. I guess that might help you. Okay, so data frame can be 2D as well. Okay, two-dimensional arrays or two-dimensional table-like structure containing of rows and columns. Okay, so you can create a data frame for that as well. And I hope I am not. We should not go into that detail because we have already seen 1D. So don't go into the 2D now. Uh, just give me 1 second. I think the file has been not be uploaded. Okay, so let's say what if I want to, sir, it's done. Like we are good with the examples of all those things. But what if I want to, what if we want to access the CSV file? Okay, what if we want to access the CSV file? How we can do that? So in Pandas, its CSV file can be accessed. Now, in order to do that, what you have to do is you have to upload a file here. Okay, in Google Colab, I'm telling you, you have to upload your file here. Okay, in sample data, I don't have any CSV file, I guess. Yeah, CSV file is there. Okay, so you have to upload your file here, and then you can access it. How you can access it for? But for you guys, I am taking what to say a file from the online. Okay, there is a file. I'm sending you the URL. Okay, in the chat, and you can access that that CSV file online, and we'll use that in our system. I'm sending you in the chat. Okay, open this URL, and yeah, pd.read, it is read underscore CSV. But how to read the URL from the URL? It generally works for the local system, local file. But since you don't have the local currently, you might not have the local currently. So we'll do that with this. Uh, okay, I have it handy, but again, we'll go with the URL part. That is something new. You'll find that. Guys, got the CSV file. You can give it a. You can open it and look into how the CSV file looks like, and we are writing the code for reading the CSV file. Okay, so let's we'll define a variable named URL, and in this variable we'll paste the URL that I have given you. Okay, so that it would create a string object, and then the data frame, we want to access the data frame. We have seen what data frames are, right? So I'll convert that into the data frame, and so pd dot read CSV. Read CSV is the function that converts everything, that converts the CSV file into the data frame file, and we can access that. Okay, so pd dot read CSV, and you can see if you leave it here, you can see the file path is something which we need to enter. Otherwise, all these are default parameters, so you need to add the file path. Okay, so I'll add the URL, type the URL name, and if I want to print the complete data, so I'll write print df, and it will print the data for me, return the CSV file. You can open and check if this is correct or not. It would be 194 rows and 2 columns, and some of the data is visible here, otherwise other is in the form of dots. Okay, guys, give it a thumbs up if give it done or something like that, if you are able to access and write this code, or you are able to do this, because it sometimes here is where here the people got stuck generally. So give it a try at least. Cool. Others as well, I guess. For others is good too, right? Okay, cool then. Let's uh let's move on then. So this is how you read the CSV files, and now you can do anything with the CSV file. It's up to you. And so yeah, that's how the CSV file works, and you can play with the CSV file. Similarly, you can access the JSON file as well. Okay, I don't have the online JSON file, but the function I would write df equals to the same thing, pd dot read JSON is this time, and you can type the JSON file path. Okay, file path of JSON you can write. Okay, and you will get the data frame from JSON as well. Okay, cool guys. So what JSON is, some people are asking. JSON is a plain text, but it has the format of an object and is well known for the in the world of programming, including pandas. And so yeah, big data sets which are generally stored or extracted in the form of JSON only. Okay, so yeah, JSON files come with a extension of .json, JSON. Okay, so let's say data.json, something like that. Cool. So there is another function called head, which returns the headers and a specified number of rows, starting from the top. Let's say currently this df prints the complete data. I want to print the number of elements. Let's say 10 element. I want to print the top 10 cells. I want to print. So I'll write 10, and oh, this will give an error because the file path specified. I'll remove that. Cool. So top 10 elements is given from 0 to 9. Okay. So top 10 values it's giving. Cool guys. So this was now we are analyzing the data frame. So data analyzing using pandas, you can say. Okay, first 5 rows again. If you leave this empty, it will print the first 5 rows. This is how it works. Okay, so it first 5 rows you can print use without using any number. Yeah. So if you want to print, let's say the last 10 rows, the head and then tail opposite of it is tail. So it will print the last 5 values. Okay. So that's the thing. And let's say I want the type of the elements. If let's say I want the null values, non-null values, or the columns, what are the columns? So what uh, there is a function called info. Okay, so will use that df.info, and it will give the info about the data we are having. Okay, so it starts from here. The class is this data frame, 194 entries, 0 to 193. Data columns, 2 columns, column country and region are the 2 columns, 194 non-null values, region also has 192 null values, d type is object, they are all object types, and memory uses this. Okay, cool guys. So this is the info. This is very important for people who are working in data analysis. They know the importance of this thing. Cool. Let's null values are very important to be handled if you are keeping your data for the if you're giving your data to the data scientist or for the further processing. It's important to work with the null values. Okay, now there can be data cleaning as well, but we might not go into that detail. Let's so that was all for pandas as well. The basics are, I think we are good with the basics. Now we'll very quickly jump to the matplot part as well. So what is matplot lib? Matplotlib is the complete term. Matplotlib is a low-level graph plotting library in Python that serves as a visualization utility. Okay, and Matplot was created by John, and Matplot is an open source and free to use as the other languages and libraries are. And it mostly written in Python, but a few segments are written in, let's say, C, Objective C, JavaScript for the platform compatibility. And I'll share you with the code base of Matplot. Again, let's get started with the Matplot, and I'll add a few extra cells so that we can use it. Okay. So again, pip install matplotlib See how it works. Already satisfied. And guys, let me know if you are done with this installation of matplot and import as well. Yeah, done. But most of the matplot utility lies under pyplot submodule. There is a submodule with the name pyplot, and most of the functionalities and the method that we use in matplot lies in pyplot. Okay, so that's why uh, we import pyplot generally. So let's import pyplot only because we don't want our system to get heavy with importing complete matplot library. So matplot lib. So that's how you write. No, that's not. Like this is how you write matplot.pyplot. If you want to access some submodule of any particular big library, you want to a small person or a small submodule. So we'll import this as plt because I don't, every time I don't want to write matplot or pyplot, matplot.pyplot in my code, I'll import this as plt. Now I'll simply write the these three one les. Cool. So importing is, I guess, done. Let's import that. Yeah, importing is successful. And now pyplot package can be referred to as plt. Now let's say I want to print a plot. Let's start with plotting a basic uh, graph. Okay, so let's say there are x points, and x point can be, let's say they are arrays, np dot array we now know. Okay, that's the order, that is why I like teaching in the order and telling in the order of numpy, pandas and matplot and then seaborn, because it always make complete sense, and it always helps you understand the previous things and implement those in the further coming modules. So that's very important. So np dot array, and now we'll write 0, 6. So it will give you the array of from 0 to 6, right? And yeah, and ypts again, np dot array, and again the same thing. X point, y point we have defined. Let's plot this using the plot function in the defined in the pyplot library. So it says xpts. Just we have to pass the parameters xpts, ypts, and there is a function called plot.show which helps you show the plot. Okay, this is how it looks like. Currently there is a linear relationship what we have defined. Cool guys, so this is your first plot in matplot library. And yeah, so basically the plot function that we have used is used to draw the points markers in the diagram. By default, plot function draws a line from point to point. Okay, by default it takes from point to point that you can see in the diagram, like connect 0 with 0, 1 with 1, 2 with 2. So that's why it's a straight line passing from 0. Okay, it generally the definition of this line is in the first quadrant it is x equals to y, right? It is x equals to y line. We all have studied in our plus 2. Let's, right, x equals y. The parameter one takes the array containing the points on the x-axis, and the parameter two would be the array containing the points on the y-axis. And okay, let's say if I want to plot a line of 1, 3 and 8, 10, so then I have to make x plot as 1, 8 and 3, 10. So that's where it will plot, because one, right, you know how it works. Okay, then yeah, let's so x, that's horizontal axis, y, it's a vertical axis. And plotting without a line, to plot only the markers, you can use the shortcut string notation with the 0, which means the string would be there. Okay, so let's say if I use here, that is I don't want the line to be there, So I'll use it like something like this, and if I run it again, so it will point dot 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 only. Let's say you don't want a complete line, you want to view your graph in the form of in this. Yeah, we'll come on to that as well. So they will come on to that as well. So let's say I want to mark only the points. I'll use that. Okay. Uh, okay. Now you can point any n number of points. Let's say this currently this line is straight, so you must be thinking how other graphs would be drawn. So let's take another example and let's see how this line works with different case. I'm taking this even and odd or something, the combination of that. Okay, 3, let's say 8, let's say 1, let's say 10. Okay, and I don't want it dotted because I want a complete line. So let's done that. You can see it will come. It basically connects 1 with 3, 8, 1 with 3, and 2 with 8, 2 with 8, and 6 with 1, right? So 6 with 1, it connects 8 with 10, 8 with 10. Okay, so automatically it gets plotted. Cool, guys. So this is how you work with multiple points and in PyPlot. And yeah, so there are a lot of things in this. We'll quickly jump into some important parts like there are scatter plots. I think we have seen scatter plots already. You can represent them here, okay, in the form of dot. And let's go to the bar charts. Okay, uh, let's start working on that. We have already imported plt plot, we have already imported numpy is already imported with us, so we can directly go and define mm, this. So on the x-axis in the graph chart, if you know what graph or histogram basically a bars looks like, a bars is like on the x-axis there are some values like a b c d, and on the y-axis there are values corresponding. Let's say there are sales, let's say for Hyundai, Tata Motors, and Hyundai, Tata Motors, and Maruti Suzuki. They are the names of the brands, and on the left hand side, they are the sales. Okay, let's say 10, 50, 30,000, 30,000. So all these are the on the y-axis. Okay, so I want to plot a chart like this, a bar like this. Okay, so how I would do that? So I would say x would take the values of numpy.array. X would be let's again Maruti. Let's take Tata and Hyundai. I'm sorry for the spelling is wrong. Uh, np.array. It would contain the sales basically of these brands. Okay, so they are in thousands. Okay, so let's say obviously Maruti Suzuki always leads, so it's always a hundred. Tata generally comes on second, and they generally comes on third or second or third, depends on Tata Motors and Hyundai. They shift on from second to third, if you are aware of the industry. Okay, so that's how you do. And plt dot that now you use the function dot bar. Okay, then x comma y and plt dot show. This will show the black merchant hopefully. Look, Maruti, Tata, and Hyundai, and 100, and 89. Cool. Okay, guys. So this is how, and now n number of bars you can add. Like you can keep on adding the values on x and keep on adding on values on y, and the size will get increasing. Okay, and yeah. So let's quickly jump to the histograms. You must be knowing that histogram is a graph showing the frequency distribution generally, and it's a graph showing the number of observation within each given interval. Okay, so yeah, so there is a random function and there is a normal function as well to generate. I will leave that. So random normal, I think I need to tell you. Yeah. So np dot random function basically generates the random values from a range. Okay, and normal function dot normals follows the normal distribution while making the random values. Okay, so I make it 170 10 and 250. Okay, in the gap of, okay, so hist is the function that is used to plot the histogram, and I'll use this function. So plt.hist and then plt.show, and if we plot the histogram for you. Hmm. Okay, yeah, sorry, I missed his. Yeah, so you can see this is the histogram. It's a normal function, so it follows the bell shaped curve. Some of you might be aware of. If some of you are not aware of the normal distribution, it's not in the part of this session, but you can google it, the normal distribution, and you will get the answer, a very good answer. Yeah. Okay, thank you guys, please supporting each other. Like that only, it would make our life easier. Okay, let's come on to the pie charts quickly. And again, pie chart in the form of pie, you know how pie chart looks like it in the form of pie, like a pizza, it will get divided. Okay, so let's quickly do that. X again, I'll define np dot array, and let's say I take values, it should sum to 100, right? So let me take let's say 25, 35, again 25, and again 15. Okay, let me take these values, and I will write plt dot py and x, and then plt dot show, make the plan. There are hell lot of properties how to, there is some label, there is some, all those things are there, but again, that is something like teaching css. Okay, if you know the basics of the css, okay, so you can google all those things on your own. Oh, someone is unmuted. Okay, cool. Cool, then I guess, so this was, I think pie chart, yeah, pie chart is ready. So this is the pie chart you can plot. There are hell lot of things, like you can mention all those things, like values will come up here, you can distribute it. So all those things are also there. Like let's say, let's do one thing, let's do this for the pie chart, because we have not used labels for any of our graphs. Let's do for pie chart at least. So let's say all these are values and I want them to be label. Okay, I want to label them, so I will write label equals to, and then I will uh, mention that, let's say it's x, and it's y, then it's z, and then it's w. Okay, these are the labels, and but in the pie I have to tell, like I am using this label things. So labels is the parameter, and I'm using the this list as the label for labeling my pie chart. I have to tell the system. Now you can see x, y, z, w. You can do that. Cool, guys. So this is how you label anything. Okay, there is a hell lot of things to explore in all these things, like pie charts, histograms, bar graphs, this normal graphs or plots. There are hell lot of things you can explore, you can work on. But again, we are not going into the detail of each and everything. Now we would, I think, we'll quickly jump into the Seaborn part, and let's see what Seaborn has to deliver for us. Okay, let's do the Seaborn part, installation of Seaborn. The same thing, pip install Seaborn, and do, guys, please do this and let me know in the chat if you are done with this installation of Seaborn. Then we'll import Seaborn and we'll do the work. Done, most of you, yeah, guys. Okay, let's import the Seaborn then. If you're done with installation, import Seaborn. Just give me 1 second. Okay, guys, last 5-10 minutes for the session, and we would be done with that. So please bear with me that, and we'll look into a more interesting topic from tomorrow, that is hypothesis testing, and we'll deep dive into that. Okay, so we have imported Seaborn. There is a dist plot. How many of you know what dist plot is? DIST plot. Any one of you know what dist plot is? Who have worked with Seaborn? No. Okay, they must be typing, but we don't have much time, so I'll quickly tell you what dist plot is. Dist plot basically stands for distribution plot. DIST distribution plot, and it takes an input and array and plots a curve corresponding to the distribution of points in the array. Okay, and so that's what the dist plot is. Okay, and we have imported Seaborn as, we'll try to import Seaborn as SNS, and yeah, and we'll use SNS dot displot, and we have to pass an array to it. The colors and all those things will automatically show up. Okay, yeah. So this is how the C1 looks like, and yeah. So Seaborn is generally used with Matplot library to basically give them the background color or something like that. Okay, yeah, cool then. I think there is another Iris dataset. How many of you are aware of Iris dataset, guys? Some of you aware with Iris dataset? Uh, Worked with Iris? Yeah. No. Okay. Do you have a link where I can register for the activity tomorrow? Yeah. Okay. Mm-hmm. Yeah, her iris photos. Yeah. So that's what the iris data set. It contains petal and all those things. So just give me 1 second. I'll send you in the link, Victor. I'll send you the link in the end. Would that work? Right? I don't have it handy. I need to look into that. Okay. Yeah, petals and all those things. Yeah. So that's what the iris data set is. And yeah. So okay. So let's load this iris data set, and here itself, yeah, here itself, in the next line we can do. So let's load the data set. So data equals to cbond library dot load data set is the function that we use to load any data set, and this time it's iris. It's already there in the cbond package. Okay, so iris, we don't have to. And let's make the pie plot, line plot basically, using the cbond. So sns dot line plot, and there are few parameters for that. There is one parameter dot sepal length is there. Okay, so in the x will mention sepal length. We'll write sepal length in the x-axis, and in the y-axis I'll write the sepal width, and then the data value I'll give it to data itself. Okay, this is the data string, that this is the data I'm using. Okay, let's see how it looks. Yeah, so sepal length and sepal width, x-axis and y-axis, and then it's there. Okay, so this is how the cbound library looks like, and yeah, you can use it to work with matplot as well. Let's say uh, you can, let's say I want to uh, set the title for this. There is no title. Title is something which comes above the table. Okay, or above the graph. So let's say I want to add the title. So I will, for this I will use the matplot library. So plt dot title is the function that we use, and I can name the title as anything. uh, Let me name it iris dataset. And if I plot dot show I have to use, because I'm using the matplot library. Look, iris dataset is the title now. Cool. Everything rest is done using the Seaborn, and this title part is done using the matplot. So this is how you can use Seaborn integrated with matplot. Okay, cool guys. You can also set the limit of x and y's and all those things, figure dark and all those things. You can also tell, like, you can change the style of how it looks like. Okay, so it's up to you then now how you style them, how you use them. So it's up to you. So yeah, I think Seaborn we have covered. Let's quickly get back to the. Let's quickly get back. I think we are good with Seaborn as well. That was the basics. All those basic and installation I have to done, so that this session was day one was to just to uh, give you give you an idea, give you and get your system ready for day two, which is more on the important side. And just give me 1 second. I'm opening something and do that. Okay, so I think my screen is visible. So we started with this on day one. We started with hypothesis testing basics. Uh, we started with types of hypothesis, null hypothesis, alternative hypothesis, and then we went to why do we need hypothesis testing. Okay, just give me 1 second. Hypothesis testing, why do we need that? And then we quickly come to the Python basics like NumPy, Pandas, Matplot, and Seaborn. And then we'll tomorrow see how to test a hypothesis in Python. Okay, so this would be the topic for tomorrow. For all those who want to attend a session for tomorrow, these will be the topics for tomorrow. Tomorrow, just like today, we get our hands dirty on the coding using Google Colab. We'll try to code tomorrow as well. Okay, we'll try to do that tomorrow. But now this time it would be uh, in hypothesis testing. Okay, cool. Then yeah, same meeting link will work for tomorrow. That just give me couple of minutes. Organizer is joining, and she might be able to answer all those things. I actually I don't have idea on that. So she might be able to give you a good idea on that. Okay, so just give her a couple of minutes. She's joining. So till day two, we'll see type one, type two error, t test, and chi square test, chi square test. Okay, resources and some good references where I have referred from. Give me 1 minute and I'll share you with the code base of that as well, of all those things like numpy where you can refer to numpy and pandas. Okay, just give me 1 minute. I'll share you with that as well. Mm, yeah, at least we for all those who have already knows all these things, it's a good refresher kind of thing, I would say. uh, Getting yourself brushed up and getting your things ready. So it's like that only. So yeah, thank you for attending the session, but please wait, they might be joining soon. And till then I'm sharing matplot, pandas, and numpy, I guess. Yeah, numpy I want to share. Numpy code base I'll also share that. You can refer to them if you have any doubts, or if anything you want, or refer to them. Thank you, Rohan. Thank you, Amit. Thank you, everyone. But please wait. They Hi guys, very good morning. Okay, so this is for all those people who have not attended or missed somehow day one of our series. And so on day one, we have seen what is hypothesis testing, types of hypothesis, and why do we use hypothesis testing. So let's start with what is hypothesis testing. Uh, some of you might already be aware of what is hypothesis. I guess in our plus two and in our college as well, we used to study make an assumption kind of thing. And we'll use to make an assumption and we name it a hypothesis, right? So again, hypothesis testing is a statistical method that is basically used to in making statistical decision using experimental data. So we have made some conclusion. Let's say I predict that my average age of my area is equal to the average age of the country. Let's say this is a statement I made. Now, what I will do in order to prove this correct, I will make some assumptions. I have made some assumption, and then I have the some sample data. Okay, I have the data of the average age of my area. I have the data of average age of the country, right? So what I will do, I will take the sample data out of the bigger data, and then I will perform hypothesis testing. Now in what we do in hypothesis testing, so there are basically two type of hypothesis: H naught or null hypothesis, or alternate hypothesis represented by H naught and HA. In null hypothesis, we'll assume that there is no relationship between or no association between the groups. Let is the opposite, like there is the average age is not equal. This is would be a null hypothesis. Other hypothesis, alternative hypothesis, would be there is a relationship between, or the average of average ages are equal. Okay, so these two hypotheses or statements basically we assume. Now will uh, how we'll go about these statement, let's see that. uh, that is what we will see in today's day two. So that till now, till this point, we have studied in yesterday. It was in much detail, but in short, this was the thing. Why do we use hypothesis testing? Because and what is the condition of making two hypotheses? The two hypotheses should be mutually exclusive, like either the average age is equal or it is not equal. Okay, there can't be any third case, right? Let's say there is a match between India and Pakistan. I took this example yesterday as well. And there is no tie or draw system. So let's say if uh, either India will win the match or Pakistan would win the match. Okay, so there is nothing in between. Either they both are exclusive events or statements. Okay, so that is how we choose hypothesis basically. Yeah. So why do we use hypothesis? In order, there is some theory which says that we are good at since it is a sample data. So if we prove false to the sample data, we can assume it for the bigger chunk. But if we make it true for a sample data, we can't assume it true for the bigger chunk. So that's why we go about hypothesis testing, all of those things. Yeah, Google Colab. Yeah, exactly. Yesterday we coded on Google Colab, NumPy, Pandas, Matplot, everything we covered on Google Colab. Okay, yes. I see some familiar places from yesterday itself. Hello guys. We were just discussing what we have studied on date one. Okay, cool then. Yeah, very good morning to everyone. And if you are ready, we can start with day two of our session. And these are the things we needed to cover on day two. We have gone through the basics of hypothesis testing. In day two, we would look into how to test hypothesis testing using Python. Okay. Okay. Night. Okay. Cool. Uh, then we'll go about different types of error. And some couple of tests we'll cover, like t-test or chi-square test. Okay. And then we'll go about some resources and references as well, what which I use for preparing the content. And then we'll enjoy our weekend. Cool then. Let's start with till this point we have covered. So let's start how to test a hypothesis in Python. So yeah, okay. So there are five main steps in hypothesis testing. Uh, First is state your firstly will make H naught or H1 or H1 or HA, you can say it. Some books or some content refers to write it as H1. We can use it as HA. HA H naught. HA and H1 refers to alternative hypothesis, and H naught is the null hypothesis. Okay. So firstly we have our hypothesis that average age is equal. Average age of my area is equal to average age of the country, and we'll assume now we have to make two hypotheses, at null hypothesis and alternate hypothesis. So we can assume any of the two mutually exclusive statements as each hypothesis. Okay, so this would be our first step. The second step would be to collect the data in the way it is designed to test the hypothesis. So second step is collection of the data, sample data, you can say, from the complete experimental data. Third is to perform appropriate statistical test. Okay, we'll see what different type of statistical tests it is required and we can do. Okay, fourth step would be decide whether to reject or fail, or to reject null hypothesis. Basically, to reject or approve the null hypothesis. That is what we'll do in fourth step. And fifth step is present the findings in your result and discussion section. Okay, so we'll write some findings. There are some values like p values there. Okay, alpha we have to take. So all those things, once we are done, we will present all those things in our result and discussion section. So this is how it will complete our hypothesis testing part. Cool. So these are the five steps we need to follow. We'll again come back to that before we go in much detail of each steps. There are few terms which I thought I should explain you before, because to make everyone on the same level. Okay, so as you can see on your screen, there are two terms, level of significance and the p-value. These are very two important terms. Please listen it carefully. How For the people who have joined this for the first time, and I'll tell you what how we go about in this series is, uh, you have the chatbot open. You can ask your doubts in the interval of the session, but what I would prefer you is, please wait till end of the session. If you have anything, you can ask. I'll share my profile as well, and you can chat me on LinkedIn. You can mail me as well. And if after the session you gone through in details of hypothesis testing and you find something interesting, you can share with me. Or if you find something which you are not getting the resources for, you can reach out to me, and I'll try to help you in the best way possible. So that is how we'll go about in this session. Okay, and if in case you want to speak something, you can raise your hand. I'll unmute you and we can have a talk. Okay. Cool then, because there might be some things which I have already planned in my content, and your doubt may be covered in that content till the end of the class, in the end of the session. So yeah, that's the thing. Okay, level of significance. It basically refers to the degree of the significance in which we accept or reject the null hypothesis. So 100% accuracy is not possible, and for accepting or rejecting the hypothesis. So basically now we have to accept or reject the hypothesis, as we have seen in step number 4, right? We have to accept or reject the null hypothesis. But but how we can reject or accept the hypothesis? 100, we can't assume that 100% data, sample data, should reject null hypothesis or should accept the null hypothesis. Okay, there should be some level of significance, what this is what the technical term is, or there should be some lower level or lower percentage with, or lower confident percentage, I would say, to decide whether to reject or accept null hypothesis. Okay, so therefore we select a level of significance that is usually 5%, is what we in industry we assume it to be. Okay, this is normally denoted with alpha. Alpha is a math symbol. You must have seen this like this. It's an alpha, and I'll show you how alpha looks like. So it look like something this. Look something like this, alpha. Okay, so that you should know like how the null hypothesis, the level of significance look like. As I'm muting few people, there is some background noise. Cool. Okay, so this was alpha. Okay, cool then. Yeah. uh hmm. So alpha value in when we take 5%, alpha value is 0.05, like it's 105%, and it's equivalent to 0.05, which means that your output should be 95% confident to give similar kind of result in each example, in each sample basically. Okay, I hope you got this point. What is level of significance? General value we take 5%, and our output should be 95% confident to either to reject or to accept the null hypothesis. Okay, and that level of confidence or level of significance is denoted by alpha. Cool. Now let's come to the p value. What the p value is? P value, or you can say calculated probability, is the probability of finding uh, is the probability of is the probability of finding the observed or more extreme results when the null hypothesis, that is h naught, of the question is true. Okay, I need to. Okay, so that is the thing. It's the probability of finding the observed or more extreme value when the results of h naught of is true. When h naught comes true, it we need to calculate by what probability the h naught is coming true. Okay, the definition of extreme again depends on how the hypothesis is being tested. We'll see all those things in much detail. We'll use alpha and p value in our one example. We'll try to code one example in this session as well. Okay, so don't worry about if you're not getting, if you're not understanding the p value to very exact, and don't try to see it very mathematically. Take it as a definition or a theory part, and practice will do in the session. Okay. So let's say if your p-value is less than the chosen significance level of significance we have seen alpha. Let's say your p-value is less than alpha, then you reject the null hypothesis. Okay. Yeah, we need to remember this. Like if your level p-value is less than the alpha, that means the probability of accepting h naught is less than the level of significance. So that is the case when we have to reject null hypothesis. That is h naught. Okay. Uh, so it also means that accept your sample gives reasonable evidence to support the alternative hypothesis. It also means that your sample supports the alternative hypothesis, that is HA, the other hypothesis defined. Okay, so yeah, so that was null and alternate hypothesis. Cool. So yeah, cool then. These were the two terms, important terms before we come into the five main steps. Now, there are again few tests I want to discuss. And so let's come to this type 1 and type 2 error. These are the two errors which generally we encounter while working in hypothesis testing. Type 1 error, this matrix is you must have seen in machine learning. If some of you are working in machine learning or data science, you must have seen it contains false positive, false negative. Okay, all those things. True positive, true negative, all those things it contains in this table, right? So I'll explain you with this. So let's say, please focus on this table only. Let's say in reality, the h naught comes out to be true. In reality, the h naught is true, and the measured or predictive is what we have measured. Okay, this is for us, and this is the reality in reality. Okay, so in reality, let's say h naught comes out to be true, and we have measured it correctly. We have measured it true as well, so we are correct. Okay, so this is your column, first row, first column. It signifies. Okay, I'll explain again for this one. Let's say the reality is that h naught comes out to be false. Now h naught comes out to be false. This is the reality, and we have measured it true. Okay, now there is an ambiguity. So this comes under type 1 error, that is false positive. Okay, again, let me explain you again. If that in reality h naught comes out to be true, okay, and the measured value of h naught is false. Now this is again an error, because h naught measured, what we have measured is false, and h naught in reality is true. So again it comes an error and the type 2 error. Okay, now f naught, let's h naught, let's say, comes out to be false. f h naught in reality is a false, and in measured terms we come to an conclusion that h naught is false in our case as well. Now this is where we are correct. Okay, that is column 2 row 2. Okay guys, I hope I'm very clear with type 1 and type 2 error. You just have to remember this table. Okay, and you just have to keep in mind that here is type 1 and here is type 2. Okay, let's quickly move to the definition of type 1 and type 2. So as you can see on your screen itself, these are the errors of type 1 and type 2, which means when we reject a null hypothesis, although the hypothesis was true. When we reject, when we reject the null hypothesis, although the hypothesis was true. Type 1 error is denoted by alpha. In hypothesis testing, the normal curve that shows the critical region is called the alpha region. Similarly goes the definition with the beta. Beta we call type 2 error, we call beta. Cool then. So this was type 1 and type 2 error. We'll see, we'll try to incorporate this in our example as well. But yeah, this is what I need to discuss before we go. Okay, cool then. I hope this everything is clear till now. Let's quickly go to the t-test. What the t-tests are there? Look, there are like I think there are 17 number of tests in for hypothesis testing, but currently we would be looking at only two tests: t-test and chi-square test. Okay, so there are the tests like z-test, ANOVA test. Okay, so tail test. So all those tests are also there. Then there is one tail test, two tail test. So all those tests are there, but in our session we are only dealing with t-test and chi-square test. Okay, now I think it would be a good idea to take these two tests after we are done with the steps. Okay, let's quickly come back to the how to test the hypothesis in Python. There are 5 steps. I hope you have got an idea how to reject null hypothesis on the basis of alpha and p-value, combination of alpha and p-value we have seen. How to perform an appropriate statistical test, we'll see that in detail, and present the findings. This you have to document. Okay, and collect the data. You have to collect the data. Okay, so I'll explain you each step one by one with an example, and please be careful with that. Okay, so let's start with step one, that is state your null and alternate hypothesis. So after developing your initial research hypothesis, I call it research hypothesis because you have might have done some research to get the data, and on that data you are predicting something, you are uh, stating something. Okay, so that's the called the your research part. Okay, so after developing your research hypothesis, that is basically the prediction that you want to investigate. It is important to restate it as a null hypothesis and alternate hypothesis respectively, so that you can test it mathematically. Okay. The alternate hypothesis is usually your initial hypothesis that predicts a relationship between variables. But a null hypothesis is a prediction of no relationship between the variables you are interested in. Okay, so let's say I am taking two variable A and B. I am stating that A is related to B. So in alternate hypothesis, it relation can be of anything like A is equal to B. For in our case, we have taken average of area is equal to average of the country. So a so this is assume this as A and assume this as B. So either A is equal to B, any relation kind of thing, equal, unequal, greater than, less than, I'm not commenting on that. Any kind of relationship is there. So alternate hypothesis, we assume that there is a relationship, But in null hypothesis, we assume just opposite to it, that is mutually exclusive. That is, there is no relationship between the variables. Okay, so let's take an example on this. Let's say you want to test whether there is a relationship between gender and height. Okay, so based on your knowledge of human psychology, or sorry, physiology, you formulate a hypothesis that men's are on average taller than women to test this hypothesis. So you restate it as, so this is your sample research you want to do. Okay, this is the research you want to do, or investigation you want to do. Okay, so you can assume null hypothesis and alternate hypothesis. This would be your first step. Okay, so in case of null hypothesis, you can say men are on average not taller than women. This would be your null hypothesis. And alternate hypothesis would be men are on average taller than women. Okay, so this is null and alternate hypothesis, H naught and HA. Okay, I hope I'm clear with this. Yeah. Okay. So last example, what we were taking was, let's say, what I have to test is there a relationship between gender and height? Okay, so there is a relationship what I want to understand and what I want to investigate between gender and height. That is, let's say, variable A and variable B. Okay, so in null hypothesis, what we have assumed that there is no relation. So we can say that what I want to investigate in this particularly, that are men's on average taller than women. This is my statement, or stating, or investigation, which statement I want to make it true or false. Okay, now for this, step one would be, uh, let's assume null and alternate hypothesis. For null hypothesis, I can assume that, let's say, men on average are not taller than women. Always opposite I will take for null hypothesis. There is no relation. That is, men are on average not taller than women. But in alternate hypothesis, will support the statement which we want to prove correct. That's why what we in the last step, what we have to prove, or we reject null hypothesis. We don't reject, or we don't accept a alternate hypothesis. We just reject null hypothesis with a certain level of significance, that was and the combination of p value, so that our alternate hypothesis will become true. Okay, so that's how we do. Okay, so H naught would be men's are on average not taller than women, and alternate hypothesis would be men's on average are taller than women. Cool. Then now let's come to our second step, that is collection of the data. Okay, so for an statistical test to be valid, it is important to perform some sampling and to collect the data in a way that is designed to test your hypothesis. So according to the hypothesis, you need to collect the data. It's not like you just have to collect the data. It should be according to the hypothesis that you have assumed. Okay, uh, if your data are not representative, then you cannot make statistical inferences about the population you are interested in. So basically, the bigger chunk we call it a population, and the smaller we call the sample data that we work on. Okay, so we make null hypothesis and alternate hypothesis based on the sample data, not on the complete population. Okay, so this was one thing. Also, the data you are collecting should be uh, kind of representative. Okay, it should be kind of tables or charts or something like that. Okay, that's why we have studied all those libraries in the day one. Okay, so in order to represent that. But again, let's come back to our step two, that is collection of the data. Okay, so let's take an example to test difference in the height, and difference between the height of men and women. Your sample should have an equal proportion of men and women. Okay, and it should also cover a variety of socio-economic classes and other control variables that might influence average height. Okay, there can be other influences that can influence average heights, like uh, it can be based on uh, region they are living. It can be based on the average height of the area. It can be based on the food they consume, or the habits they follow, or like the use cases they use their height for. Okay, so different the height and all those things depend on genes, they depend on the habits we do, they depend on other socio-economic uh, factors as well. So you need to consider those parameters as well in your data. It shouldn't be like this man, this height, this gender, this man, this woman, this height, this gender. It should not be like that. It should consider socioeconomic classes. Also, the data should not be, there is a term called uh, class sampling imbalance or class imbalance, which in machine learning, sorry, I'm deviating from the topic, but there is a term called class imbalance, which is basically, let's say you have the data of men's more in number and you have data of women's less in number in your data set. So men's is one class, women in another class. So this type of differences is a class imbalance problem. This creates a class imbalance problem because you don't have sufficient data of men or women to test uh, the the model. Okay, so this causes the class imbalance. So there are two procedures to proceed with that. Either do upsampling, like you can increase the data of the women or the men, either with either way you can do. This is called upsampling, or you can reduce the number of the data of, let's say, man or woman, which is lower in number. You can which is more in number, you can reduce that data so that equivalent data we have. Okay, so though these are two methods, upsampling, downsampling. Okay, leave it. Let's come to the step two, that is collection of data. So in order to do that, we should have this equivalent number of men and women, all those things. So you should also consider the scope, that is for one country worldwide, what you are considering the scope. So you should also take that into the consideration. A potential data source, if you ask me, in this case might be the census data that our Indian government, that worldwide is used by different countries. So that can be a potential data source because it's important for us to uh, identify the data source as well. Okay, since it includes data, census data. Why census data? Because it includes data from a variety of regions, variety of social classes, and it is available for most of the countries around the world as well. So we try to look into the data which is open source, which is easily available. Also, it is reaching to the all the type of regions and social classes in the society. Okay, so that is the part of collection of data. So that was our step two. So step one, h not stating null and alternate hypothesis. Step two, collection of the data. Cool. So these are the two steps. I hope this is clear. Yeah, no worries. Okay. Mm, yeah, let's move on to our step three, which is perform an appropriate statistical test. Okay, now Uh, there are a variety of statistical tests available, but they are all based on the comparison within group variance versus between group variance. I'll explain you both the terms. Within group variance means how spread out the data is within the a category. How spread out the data is within, let's say, how spread out the, let's say, let's take an example of men's height. Okay, so men's height, it should not be like the men's, all the men's are having the data we have taken. The height of the men's would is between, let's say, 6 foot 6 and 6'5". Okay, 6 foot and 6'5" Okay, it should not be between the most of the data, let's say 100 data of men's we have taken, so 90 of them sits around 6 and 6'5". Okay, and the 10 are distributed between above that, some 1 2 are above that and some are below that. So the concentration of the data is within the group variance. So this is called within the group variance. And between the group variance means how different the categories are from one another. Like the categories should be different, right? In this case, but in our case, the datas are mostly would be different, like men's and women's. Okay, so they would be between group variances will be more, right? So we have to take care of in within group variance as well. So statistical tests are basically based on that. It's like that. The statistical test that we will perform would be based on these two things: within group variance and between group variance. These are the two things. Also, so if the between group variance is large enough, let's say the within group variance is large enough, so that there is a little or no overlap between the groups, variance is comparatively large. Like variance is large, uh, we shouldn't go into much detail of the statistics because that's again a complete topic for the 2-3 hour session. But variance, I hope you understand what variance is. Distribution of the data, you can say how the data is divided on points to points. Okay, something like that. So if the variance is more, just understand that if the variance is more, there is a good spread of the data across all the values. Okay, it's not like 90 people are having the height from 6 to 6'5". Okay, if the variance is large, the data is pretty much widespread, that there is no or little or let's say no overlap between the groups, and then your statistical test will reflect that it is showing a low p-value. If the group variance is large, it will your statistical test will reflect that it is having a low p-value. Okay, this means it is unlikely that a difference between these groups came about by a chance. Okay, alternatively, if there is high within group variance is high. Look, that was between group variance was high enough, that is between the two groups, like men and women. There is no overlap, there is little overlap. This means that your p value would be low. If your p value is low, there are high chances that alpha might get the null hypothesis might get rejected or accepted. Cool. Alternatively, if there is a high within group variance, okay, and low between group variance. Okay, now understand this use case. Let's say there is a high within group variance, like within the group, within men, within women's, there is high group variance, and but there is a low group variance between the groups. Between two groups, there is low uh, group variance. Then your statistical test will reflect that your statistical test will reflect that, and it will reflect using the high p value. Okay, this is something you need to remember. Okay, kind of. Also, you can go dive in detail of p value, what p value signifies, and in terms of group variances, and you can look into that. Okay, this means it is likely that any difference you measure between the group is due to chance. Okay, so in short, your statistical test will be based on the type of the data you collected. Okay, so depending on that, you have to do the statistical test. Okay, I hope I'm clear at till now. And yeah, we'll take an example, Nupur, and let me know if after that it's clear for you. Okay, so let's take the same example what we were taking from last two steps. Based on the type of the data you collected, let's say you perform a, a type of test. Okay, x type of test you perform, whether the men's are in fact taller than women or not. Okay, so now this x test, let's say x, I'm calling the test as x. Now let's say this x test gives you an estimate of the difference in average height between the two groups. Also, it is showing a p value which is likely to see this difference if the null hypothesis of no difference is true. Okay, it gives two value. Basically, you perform a x test, it gives you two value, an estimate of the difference in average height between the two groups, men and women. Okay, the second thing it is giving a p value showing how likely you are to see this difference if the null hypothesis of no difference is true. That is, the null hypothesis of no difference is true, how likely you are able to see this. Okay, basically that is what a p value tells, that how likely or what is the probability of null hypothesis is true. What is null hypothesis? Is there a relationship or is there a difference between uh, the two groups we have taken, right, or the two variables we have taken, right? So that's what a null hypothesis. So basically, in short, it gives you a p value and the estimate over the difference of heights between the two groups. Okay, so the x test you perform shows an average height of, let's say, some 175 centimeter for men. Okay, let's take an example of 175 meter for men and an average height of 161 centimeter for women. Okay, so now an estimate true difference is ranging from 10.10 centimeter approximately to infinity. Cool. Like there would be a difference of 10 centimeter and to infinity. Now, thus the p value comes out to be 0.002. Cool. That was the p value we get. Okay. So I hope that was clear with that example. And let's come to yeah, let's come to step 4, which says will also, if you are not getting some part, will also do it in the code. And how, if you're thinking how in the coding section or how in the coding part it will be implemented, I assume I tell you that the p value we are currently dealing with, the test we are dealing with, will do this in the code as well. Okay, in the Google Colab itself that we have used yesterday. Okay, in the same Google Colab notebook, will do the coding part of this. Okay, if there is any doubt, I'll take in the end of the session. Till the end of the session, hopefully it will get cleared. Okay, let's take let's quickly move on to step number 4, and then we'll discuss about step number 5, and let's jump to the coding part of this. Okay, step number 4 is decide whether to reject or fail to reject or fail to reject. Basically, decide whether to reject or fail to reject your null hypothesis. This is what we need to decide, because if we reject null hypothesis, we are accepting alternate hypothesis. If we fail to reject null hypothesis, it means we have to accept null hypothesis. We have to, then we are rejecting alternate hypothesis. Okay, so these can be the two cases. Are they again mutually exclusive? Okay. So let's say based on the your outcome of your statistical test you perform, let's say X test you perform, you will have to decide whether to reject or uh, accept or fail to reject null hypothesis. In most cases, you will use the p value that is generated from the statistical test. uh, that will help you to make your decision. Okay, but in most cases you uh, predetermined the level of significance for rejecting the null hypothesis will be 0.05. Okay, your predetermined value of level of significance, that is alpha, for rejecting null hypothesis is 0.05. That is what we have mutually understand, and we mutually understood, and we have finalized that let's say the predefined value of alpha for rejecting null hypothesis is 0.05, that is 5%. We have already seen in the definition of level of significance that this is what the general value we take. Okay, that is when there is a less than 5% chances 5% chance that you would see these results if the null hypothesis were true. Okay, in some cases, researchers try to choose a more conservative level of significance, such as 1%. Okay, there might be some cases. Again, the level of significance depends on the type of research you are doing, the topic of research, the sensibility or the sensitive information of the data you are using, the sensitive topic or the statement you are making. So level of significance depend upon that. Okay, and this is something you will get with experience. And experience you can try working on some examples which are available on internet, and you so that you will start getting an idea of the level of significance more in detail. Okay, so why they use a lower level of and a conservative approach of choosing a level of significance, just in order to minimize the risk of incorrectly rejecting the null hypothesis. It's not always like the statement we are making is always true, and we should not have that approach in our mind that this is the statement I'm making and I want it to be true. So anyhow, by hook or crook, I would reject null hypothesis. So you don't have to take, okay, I'll take 95% as level of significance. It's not how the things are going to work. Because if you take this level of understanding and this uh, result conclusion document to your senior or some the let's say client or someone you are reporting to, it will reject that the level of significance is too high, and the null hypothesis, you have not given a fair chance to null hypothesis to come back. Okay, so in order to minimize the risk of incorrectly rejecting the null hypothesis. Okay, that if you come back, So that's why we take less level of significance. If you come back to our present our this slide, you can see if this it will come into type 1 error, right? It will come into type 1 error that in reality h naught was false, but the measured h naught was true. Cool, leave it. It was not. Yeah, so this step 4. Step 4 we were on. And let me give you an example. If your analysis of difference in height of men and women, you find that the p-value is 0.02, okay, is below your cutoff of 0.05, right? 0.002 is below our cutoff of 0.05. So you decide to reject your null hypothesis of no difference. Your null hypothesis of no difference, you will reject, right? Your alpha is more than the p-value, so we'll reject null hypothesis. Okay, so this is how the rejection part is done. Okay, I hope this step would be the easiest because you have already have the p-value, you already have a level of significance, that is alpha. If alpha is greater, accept. If alpha is greater, reject. If alpha is smaller, accept. Cool. So this was step 4 of testing the null hypothesis, testing the hypothesis in Python. So last and the most important one, that how to present your findings. The result of hypothesis testing will be presented in the result and discussion section of your research paper. So let's say you are writing the research paper, because uh, most of the hypothesis testing you would be doing would be either for client or for your research paper or thesis paper or your, let's say, your patent or something like that. You must be, so there must be a discussion and result section in your research paper that okay, based on this p value, this level of significance, I reject the null hypothesis, and this is my finding, that there is no let's say, what the example what we were taking, that there is no difference between, there is no relation between the gender and height. Okay, or if there is a difference between, there is a relation between gender and height, whichever be the case possible, or whichever you get the output. Okay, so you need to present all those things in the result and discussion section. So in the result section, you should give basically a brief summary of the data, a summary of the results of your statistical test. Let's say we, in our case, we assume it as x text. For example, the estimated difference between the group means and associated p-value, all those things you can mention in your result section. And in the discussion section, you can discuss whether your initial hypothesis was supported by your result or not. The initial hypothesis or the statement you started with was supported by your result, or it was not supported by your result. Okay. And in formal language of hypothesis testing, we talk about rejection or failing to reject the null hypothesis. You will probably be asked to do this in your statistical assignments or in your statistical paper as well. Okay, so in our example, what we will write in the result case, so uh, in our comparison of mean height between men and women, we found out that the average difference of 10 centimeter and a p-value of 0.002. Therefore, we can reject the null hypothesis that the men are not taller than women, and conclude that there is likely a difference in height between men and women. Okay, we reject the null hypothesis that the men are not taller. We reject that because the p-value and the alpha value combination comes out like this, and thus our conclusion or our statement, initial statement, was right. Okay, cool. So guys, I think it's okay. Actually, I'm not using the whiteboard. I'm just looking at your screen and then just explaining. I'll give you the proper code base and proper reference link if you want to refer to, for if you like whiteboard. Okay, I'll give you the proper link for that. Actually, I didn't use whiteboard for that. So yeah, that's the case. Okay, so guys, if before moving to the coding part, would you like to take a quick break of 2 minutes so that we can take a quick break of, let's say, 5 minutes, 5 or 10 minutes, and we can come back? Will that be fine? Yeah, we can grab some tea, coffee, or something. Yeah. So I don't think this session will. The only part I think we are left with some tests, couple of tests, and that too are very theoretical. And the coding part, I guess, that would that wouldn't take 10 to 15 or 20 minutes. Although we were supposed to end it by 11 a.m., so we'll end it before 11 a.m. Yesterday we ended, I think we extended the time by a few minutes, but today we'll end it in before time, because yesterday the topics were more, and everything was on zero, on a scratch. So that's why it took more of us our time, but today we'll try to end it before. Okay, so that some of our friends from US also don't get trouble. Okay, cool then. We'll take 10-minute break. It's 9:52 a.m. In India. Let's meet at 10:05 a.m. Would that be fine? Nice. A short 10-minute, 10, 12 minutes break. Cool with everyone? Till then, what I can do is I'll share you with the presentation, and you can go through the resources if you want, so that it might save your time as well. Okay, or what I can do is I can uh, share you some link, not the presentation. I'll share you some link so that you can get an idea of a few things here. You can refer to this. Mm. GitHub links I'm also sharing, so that you might help you to get the coding stuff after the session. Okay, cool then. Let's meet after 10 minutes, and let's. Okay, guys. So let's start, and yeah, I think hopefully everyone is back and we can start. So yeah, these were the 5 steps we have seen in detail how, but mostly theoretically we have seen all those things. Now let's write some code and start sharing my Google Colab screen. Also, well, for all those people who have joined today itself, I'll give them some ideas on what we have studied part. So this is the collab sheet, Google Colab sheet. I hope you are able to open that. If in case, let me start from scratch. So you just have to type Google Colab, sorry, and open the first link, google.research.google.com. Open a new notebook, and voila, this is what you will see in on your screen. This is a new notebook. You can code anything, and this is the play run cell button. You can press it. Also, you can use the control plus enter key to run it. Okay, if in case you want to add others key, like you can add, you can type multiple lines of code in the same cell, or if you want to add a separate cell, you can add using control plus m plus b, or you can add here. You can click on and can add as number of cells as you want before, and then you can start coding. Cool. There are two things, like if you run something, either it can turn to red. Okay, if it turns to red, that means there is some error, and the error message will be shown below. And if there is no error, it will come with a small green tick like this, which says their code has successfully compiled without any error. Okay, so that's the thing. Cool. Yeah, so let's so we yesterday we have already created a notebook, and so all those people who were not yesterday, please create your Google Colab sheet. This is what notebook, this is what we would be using in today's class as well for hypothesis testing part. And yeah, let's jump to the, so basically four libraries we have seen yesterday. One was NumPy, other one was pandas, third one was matplotlib, and where it is, yeah, here it is, matplotlib, and the fourth one was Seaborn. So all these four libraries we have seen, or modules we have seen in yesterday's session, and I'll give you a quick introduction about all those uh, libraries, and we have more than sufficient time to complete uh, our hypothesis testing code part, so don't worry on that. Okay, cool then. Yeah, so if any library you want to install, you need to type pip install and the name of the library. It will install. Since my requirements are already satisfied, it will show you some message like this, that requirements already satisfied. If it gives an error, let's say if I type pip install num, I hope num won't be some id. Okay, num is an id. Okay. I thought it won't be an id. Let's say I give let's say this, I made some error, I made some mistake. Okay, so this is what it shows like, and a red button will tell that your this comes with an error and syntax error, invalid syntax. Okay, so Google Colab has this very one good already integrated thing that that you can search directly on the Stack Overflow. If you click on it, Stack Overflow with the proper keywords, is because both of them are from Google, are products of Google. So they come with very good keyword space, so that you will get most accurate answers possible for this error. Okay, so and you can search your answer and you can edit it accordingly. So I know the answer. It's like it would be like this. So pip install numpy, requirements are already satisfied, so this cell will run good. Now in order to import any library, you need to write this import statement, import keyword. After import, you need to press space and then numpy, and then s and np. Okay, so np is like in our code base, we have to use, there would be some methods, there would be some variables related to this like module, like numpy, right? So every time I when I want to enter, when I want to use any method or any variable related to numpy, I have to every time type numpy dot this, numpy dot that. But this would be a bit tedious job to do. So what I have done is I have assigned a short representation of numpy, that is np. I call numpy as np, and so that is how you that is how you write. And let's say in pandas, I have assigned import pandas spd, import matplotlib. There was a big library in matplotlib.pyplot as plt. Okay, what this pyplot is, pyplot is the sub module of matplotlib, because the most of the function that we are using in pyplot, in matplotlib, are contained in this pyplot sub module. So we are uh, using that. Okay, so we are just importing that. We are not importing the complete module. We are importing the sub module of the bigger module, so that it reduces the burden on our code base. Cool then. I think we are good to go ahead, I guess. Okay. Yeah. So yeah, let's come where we were. Yeah. So numpy, import numpy as an np. I'll run it. You can see it ran successfully. And now numpy, what numpy is used for? Numpy is used for numpy is famous for the array, the manipulation, the all the things we need to do with array. So it's famous for that. And that's what we are doing. We'll use an array function. So np.array, array, and in the array, this array function converts anything, any list or anything of the continuous form to the numpy array. NumPy array is of the type nd array. I'll show you the type of the NumPy array. So it's type arr, and If I run it, so it will show you the type ND array, numpy.ND array. So ND array is the object, type object of the array in numpys. Cool. So this is how we can define and initialize a numpy array. And if you want to print the numpy array, print is the function that we use. ARR is the name of the array. Okay, so print ARR will print the numpy array. Okay, it can be initially it's a list. If it can be a tuple, it can be any other data type as well, but it should be continuous. Okay, cool. So this was NumPy, and let's say I want to see. Sometimes in our industry, in our when we write the code, we want to check whether we want to verify whether the NumPy version that we are using is the latest one or is the more required one or the appropriate one that we require for the particular system or the software or the use case. Okay, so you can use this particular command np dot underscore underscore version underscore underscore, and yeah, that's what you can use, and it will print you the version of the NumPy. Cool. Now pip install pandas. Now let's come to the pandas part. Couple of more examples we have seen on NumPy. Not going much in detail because others would get bored much more. So not going in much detail of that. But yeah, this was NumPy for you. Importing NumPy and playing with arrays is what NumPy does. Okay. Now let's quickly jump to what pandas does. Installation of pandas, the same thing. Pip install pandas. And importing a pandas, import pandas, or requirements are already satisfied to it will get successfully installed. No worries in that. Now importing pandas as PD will import pandas as PD. Now you can import pandas as PD. I think Google Colab. Uh, should we? I think it would work in the same way because Google Colab is, I think, is a website or web portal, so platform. So I think it would work in the same way, independent of your system and requirements. That's why I use Google Colab. Okay, also guys, if you don't want to use Google Colab, if you have Anaconda or Spider or any other software which runs the Python and machine learning data science code successfully, you can also use that. Okay, I'm using Google Colab because there are different people from different areas and different system requirements as well, so that's why. Yeah. Okay, so import pandas. Now pandas take it as a dictionary. Let's take pandas. Give a pandas a dictionary, and the data frame is what pandas use. It's ND array for NumPy, so it's the same as data frame what pandas library use. Okay, so pd dot data frame, pd again pandas library. So pd dot data frame, it will convert this dictionary into the data frame. Will store it in my where and print my where. It will print the form in the tabular data. So basically tabular data, dealing with tabular data, dealing with missing values, dealing with all those things you can do. Yeah, it should be. You can do again. You need to check the requirements. I have not coded in VS Code this part, but I think you can do. Yeah, you can do. But the system requirements you need to check, like some installation of libraries and extensions is might require in VS Code. But once you are done with that, I think you would be able to run them, run these things. Yeah. Look, so dealing with the tabular data on all those rows and columns, we use pandas. Cool. Now, pandas mostly are, since tabular data. Now, where to get the tabular data from? We just can't keep on creating all those datas. We have to have some external source. We might require some external source, some in some cases, to deal. with. So that's where the use of read CSV, read JSON, all those functions of pandas library came into the picture. uh, so let's take an online URL, online CSV file. Let's store the variable in the let's make a URL variable and store the online CSV file, and that URL as in the form of string, and then we'll pass it in the read CSV function, which basically reads the CSV and pass it in the data frame object, and we can print the data frame object. So printing DF or data frame object completely means it will print all the rows and columns with the numbering part as well. Okay, but if let's say if you want to print only the first 10 first 5 or first 10, or let's say first n number of entries basically, so what you can do is you can use the head part, and if you leave it empty it will print uh, the top 5 entries. If you like write 10 inside it, it will print the top 10 entries. Okay, there is also a tail thing, tail function. If you want to print uh, values from below of the table, like from the last of the table, top 5 below 5 values it will print. Okay, there is also a info function that we used yesterday, and that tells you, that will give you the idea of the data you have, like how many non-null values. This is very important because null values, non-null values, missing values, all those things we have to deal on the daily basis in the data science field and in the data science pipeline. Cool. So info is very important function. So yeah, that was uh, now read CSV. You can read CSV from the local system as well. If you have CSV, you can upload it here. Okay, you can upload it here as well from your local system, and if you have it in the system as well, you can read it, and this is the command for that. Read CSV, and the name of the CSV will appear, and the simply the same thing that we have done over using the URL. Cool, I guess. Then JSON you can also read. You can add a JSON file, and you can read the JSON as well. We have done that as well. And yeah, I think hmm, cool then. Yeah, that was one thing. And yeah, so that was mostly the basics of pandas for us that we might require in the session. So let's quickly come to the matplotlib. Matplotlib is a library basically which helps you to plot your data in the form of graph, in the form of histograms, in the form of pie chart, in the form of various other methods of visualization. And some of the data analyst working there, or business analyst working there, you might have to give some representation of the data in the form of pie chart, graphs, or pie plot, or histograms, or all those things you might have encountered, and you might have send it to the business team, to the data science team, right? So you might be aware of the matplotlib, although you might be using some higher other libraries in combination of matplotlib. That we in this course also, in this session also, we have used Seaborn in combination of matplotlib, so that you must be using in your daily work. Cool. Then matplotlib, again the same thing, importing as PLT. Just we are importing the subplot, sorry, pyplot, that is the sub module of the matplotlib. And yeah, let's import that. Let's import numpy, and this x points will give you the array of from 0 to 6, and this y points will give you an array of like this. And the plot function will help you plot x points and y points. uh, Actually, it should be the thing is the pyplot is just a module. We are just naming matplot.pl pyplot, this complete thing as PLT, so that whenever we require to access here, like we are require this array function is from numpy. Okay, we want to use it. We want to use this array function from that is already defined in the numpy module or in the numpy library. So we have to write numpy dot array. So instead of that, I have renamed numpy as np in our code. This is called alias, and np alias, and I use np as np dot array. Okay, so that's why we have used plt for that. Okay, I hope it's just a representation. It's not something different. It's just a representation we have used. Okay, I hope I understood your doubt and clear that. Okay, plt dot plot. Plot is the function that plots on the that helps you plot basically, and plt dot show will help you show on the graph. That's the function uh, you need to remember, kind of plot and show. And every time in every visualization code and visualization script, you will use basically these functions, and that's how it will go. Okay. Okay, so that was matplot. Yeah. So we have also plotted the pie charts. In that, you can go through uh, the .ipynb file that I have shared in the chat. You can go through that. I have shared that is with the learn Learnbay day one. Okay, and you can look into that. I have also written the code. We have also written the code and discussed the code of plotting the pie charts in that. So yeah, that was another thing. Now let's quickly come to the Seaborn, and then we'll go to the our main topic of hypothesis testing coding part. Now, uh, Seaborn, yeah. So let's import Seaborn and SNS. I'll import Seaborn as SN and matplot pyplot as PLT. Now, SNS dot displot. This will plot on the graph, and PLT dot show, which will help us in showing that. And you can see this is how beautiful it looks like. Now, a couple of more examples we have taken, like we have also used the label kind of thing to label this complete graph that you can find in the sheet. I'm not repeating it again. And this is how to draw a line plot. This is how to load the dataset, iris dataset. I hope you might be aware with the iris dataset. It contains the petals or sepals thing. Cool. So that's how it does. And yeah, so importing package and Seaborn. Yeah. So till this we have uh, covered. We have covered, and you can find the code in the chat as well for all this and way more in detail. We have covered. Cool. Now let's come to the part. I hope everyone is back again, and let's come to the part of hypothesis testing using the code. Let's write the code for that. So we'll start with importing numpy. So importing numpy as np, and I hope it will work. So I'm writing the all complete code in one cell itself. Okay, and then I think we would require pandas. So currently I'm importing all the libraries that we would require. So importing numpy as np and pandas at pd, right? Here you can see the definition of pandas as well as a Python package providing fast, flexible, and exhaustive data structure, blah blah blah. So you can find that as well. Cool. Now let's store the null outcomes. So we'll make a variable with the name null outcomes. Let's store that. This is the list that we are making, like empty list, you can say. Okay. Let's make the observed values. Let's assume that the observed values are 41. You can take any random number. I took 41. Let's say. So let's simulate the null distribution. Let's simulate our null distribution basically to make a null distribution. Okay. So I can write simulate. I'll go about writing the code with the comments as well, so that if in case you read this in the future, you would have the reference like why we have written this. Okay. So this is how you write the comments in Python for all those people who are new to this. So this is how you write the code in Python. The comments generally not uh, executed or on the system. Okay, they are just for the reference of the coder or the client. Okay, simulate the null distribution. A very small example I am taking. where we'll simulate a binomial hypothesis test, let's say X test. We are simulating using the following null and alternate hypothesis. Okay, the null hypothesis that we are taking, we would take is that the probability that a visitor to a website makes a purchase is zero point 0.1. Okay, this is the null hypothesis that we are assuming that let's say we are working in a e-commerce company, and the probability that we have to make, we are asked a question from the client or the business stakeholders that what is the probability that the visitor to a website makes a purchase. Okay, and let's say we stated a percentage of a particular percentage of the purchase that he makes, let's say 10%, 20%. Okay, so now he is asking that prove me wrong, or like prove your answer is correct using the test hypothesis testing, or you have to submit a report mentioning all those things. Okay, so we are doing for that. Okay, so yeah, so what we'll do, we'll take the null distribution of, let's say, um, 1 lakh employees, 1 lakh people, customers, all. So for I in range, I hope this small syntax I don't have to explain you much, right guys? 2 3 4 5. Now we'll write simulated visitors. I would the good choice of the name of the variables is very important while writing the code for all those who are currently studying and will be entering in the industry. I'm just making few points or tips clear for them. Like choose a good choice of the variable is very important, and the name of the variable is very important, so that I could have used X, and it would have X instead of this, and it would have worked fine, completely fine in my code as well. But again, if you are an observer, if someone else is viewing your course or code, or going through your course, it is important. Then we have basically taken it. You can assume it anything. It's a sample data, you can say. A sample data. I told you now, the sample data we take, from the big population, we take a sample data. Yeah. Yeah, selecting right variable and selecting the right name for the variable are two different things. Selecting right variable is a part of the pipeline, and selecting the right name of the variable is something your personal choice, or the call you have to make while writing the code. Okay, so there is, I think, a quite difference in between these two things. Okay, cool then. Simulated visitors, let's it would be complete random. So random dot choice and p dot random. I think you are aware with the random and choice libraries. They are very basic libraries where you can see it generates a random sample from given 1D array. Okay, this is the syntax of that. So in the choice there is one variable that we have to define, that is a. Okay, so a would be in int, so we'll define that. Let's say yes or no, y or n. And uh, all those things, all those small, since it's a random data, we are simulating the null distribution. Okay, so all those things that I'm assuming is based on my assumption. You can assume anything you want. Okay, you can perform your experiment, you can take out a p value out of that. Okay, you can assume, you can take out other value out of that, and it would work for you. Okay, so all those things you need to check. Okay, and you need to experiment basically. Size I'm taking is for the simulation uh, would be, let's say, 500 would be good, and the p I would be taking as, sorry, p would be taking as zero point 0.1 to 0.9. Okay guys, let's say the minimum purchase that they have made, or the number of purchase that they have made comes out to be np.sum, and where the purchase would be made when the simulated visitors are yes, right? It comes in the category of yes. So we'll have to make this some sorry, we have to make the simulated variable simulated visitors as equals to yes, right? And now with this, the null outcome, that the null outcome we are getting, we have to push all those values, the number of purchase values we have to pushed inside the, has to be appended or pushed inside the null outcomes. So in order to do the further calculation of the p values, right, we need to calculate. So our aim, what is our aim in the hypothesis testing? If you carefully understand, firstly we have to assume h naught and h naught and ha, that is null and alternate hypothesis. For the null hypothesis, uh, we have chosen that the probability that a visitor to that a visitor to a website makes a purchase is, let's say, 0.1, or let's say 10%. Okay, the total number of, let's say, 100 visitors visiting, so only 10 people are making the purchase. Let's say for Mintra, 100 people are visiting at Mintra website, or let's say big billion day, or Amazon, uh, whatever they call, they 10% people only visiting their website makes a purchase. Okay, so that is the null hypothesis. And what's the alternative hypothesis? That the probability that a visitor to a website make a purchase in less than 10. Okay, so these are mutually exclusive, right? Either they make 10%, either the purchase 10% people are making purchase, or less than 10%, right? There can't be both the cases, right? They these two statements can't be true simultaneously. That is what we are looking for, and that is how we define the hypothesis. Okay, so null and alternative hypothesis, these two are done. Now after this we need to calculate. Okay, the ultimate aim is calculation of p value, so that we can compare it with alpha, and we can comment on the null hypothesis, whether it is to be rejected, or we fail to reject it. So if we reject it, alternate hypothesis is true. If we fail to reject it, null hypothesis is true. Okay, I hope you uh, I am clear with that as well. Cool, then let's quickly complete the last couple of lines we are left with. We just need to append all those values into null outcome. I have null outcome list. So null outcomes, I'll append that. Append the number of purchased items, number of purchase. Okay, purchased. Being careful so that I don't make any uh, silly spelling mistakes. So now what we'll do, we will calculate the p-value. We'll calculate the p-value. That is our final and most important part. We'll convert this null outcome into the array, as you know, null outcomes to the array. So np dot array. That's why I was that's why we gone through the complete day one and spent our day one in studying NumPy, pandas, and matplot, so that you can plot the graph, you can convert them in array, you can play with all those things. Okay, right? That was the initial aim of my of our day one session. Okay, so NumPy dot array. Now I think you must be feeling comfortable with writing the codes for that. So it converts the null outcomes in the form of array, and then calculation of the p-value. Let's define a variable with the name p-value, and we'll give it a value of np.sum. Will sum, what will sum? Will sum the null outcome. Null outcomes, I'll explain you this, and the observed value as well. We'll take into consideration observed values as well. It's already defined. So, and one important thing that we are missing with is it should be, since it is a probability, so it should be divided with the number of null outcomes. So length is the function which gives you the number of null outcomes are there. Okay, so null outcomes are there. And once we are done with this, we'll go about and print this basically. So we'll print that p value of this case is equals to, let's say, uh, p underscore value. Okay. Now let's see if the some error comes or how it works correct or not. Okay. Hopefully it should work fine. I don't see much mistake. Okay, num outcome is not defined. I think we have named this. Okay, this we have named it wrongly. Null outcome it should be. Num outcome is nothing. Num purchase is there. Null outcome is there. Yeah, p value. Okay, successfully it ran and p value comes out to be this. Now you can compare with the alpha, you according to your choice, the alpha according to your case, your client, your business holder, whatever alpha or level of significance they want. Like they say, okay, I want 10 purchase, 10%. Okay, so in our case we have assumed 10%. So it's that is null hypothesis is 0.01, right? Zero point 0.1. So the p value is less than that. So we'll reject the null hypothesis and we'll accept the alternate hypothesis, and thus we got the result. Okay, so that's how you implement the null hypothesis, and that's how we go about it. Okay, guys, and repeating it correct. Okay, you will get the recording. No worries. I think Karishma will provide you with the recording on the YouTube channel, and you can go through it once again. And and if you have anything more, so yeah, Rohan, you can go through that and let me know in the chat as well, or in the on my LinkedIn ID or my mail if anything you find after you have gone through the recording as well. Yeah, so that was the thing. So that was all I think from our side, from my side. Okay, I hope you got the idea. I'll quickly share. Give me 1 minute. I'll quickly share this with you. Dot this file with you, and so that we can. Okay. Yeah. Yeah. So this was day two, completion of the day two. So yeah, guys, that was all I think. The YouTube channel link that Karishma would share. Okay, and yeah, over to you, Karishma. Thank you, guys. Thank you for being such a nice audience, and I hope you must have enjoyed and you have learned something new. And if you have anything, you can ask me on LinkedIn. You can chat us. Thank you, David. Thank you.